Good morning, everybody. We'll give it a few more minutes as people are joining. So I will post here in the chat a direct link to the YouTube broadcast if you prefer watching it on YouTube. We will give it a few more minutes and we will start shortly.
Hey Ryan, there's a question already on which version of R should they install.
Great version. If you have a recent version, that's going to be fine for this class. If you haven't installed R yet, go ahead and grab the latest version of it. But version, what is it, 3? I think we're in version 4 right now, but 3+ should be fine as well. So, but if you're new, just grab the latest version off of the R website.
Okay, I think we can go ahead and get started. Welcome back, everybody. I am very happy to see that we're all here. It's now day 5 of my Institute on Computation and Statistics for Mass Spectrometry and Proteomics. And it's been very intense and a lot of information, but hang in there. So today and tomorrow, we are shifting gears a little bit, and we are talking about R. And the reason why we decided to include R into this program is, well, there are several reasons. One is because we want to make sure that we have the ability to work with our data and analyze our data in ways which are as customized and as independent of the other tools as possible. Also, because many tools in our community rely on R, in particular rely on Bioconductor, and also because being able to do data analysis in R rather than, say, in Excel really helps reproducibility of our results. And all of these reasons are really important for mass spectrometry and proteomics. So if you have never used R before, never fear. So this is why we're here. And we have amazing instructors who will walk us through all the steps on how to get first exposure to R. But before we start, let me just walk you through some logistics if you haven't been with us previously. So at the bottom of the screen, you have 2 buttons. So there is a chat button. So we usually use it mostly for things such as, hi, how are you? I can't hear, but we try to not use it for anything related to the presentation or anything related to the science. If you have questions to the instructors, please use the Q&A button. So the Q&A allows us to manage the questions more effectively. It also allows us to save these questions at the end. And what we will do, we'll post these questions to the docs link at the end of the day so that you can review these questions as well. So you do not have the ability to speak and share screen now. However, you can ask the teaching assistants for additional help. So what we can do if you're really, really stuck and you're really, really not sure what to do next, our teaching assistants can paste an alternative Zoom link into the Q&A so that you can join them in the different Q&A. At the same time, you can continue watching the main presentation on YouTube. So I posted the link now, and I will post it again as more people join. And at the end of the session, also, we have the ability to promote you to panelists, so you can actually speak face-to-face and share your screen with the instructors and so on. So there are quite a few ways for us to be interactive, and we truly hope that by the end of these 2 days, you will be able to do some work with your own data. on your own. So please do not hesitate to ask for help as much as possible. So now let me introduce our speaker. I am really, really excited to welcome Ryan Bentz as our instructor for today and tomorrow. So Ryan holds a PhD in chemistry from the University of California, Irvine. But however, while being a chemist, he is now a data scientist at Seer. And so Ryan works extensively with R as part of his daily work. Ryan is also an accomplished educator. He leads multiple R-centric educational efforts. In particular, he will be working also in a short course at ASMS, which is coming up in several weeks. So we are very, very grateful to Ryan for his time that he can spend with us today. And so let me also introduce the teaching assistants, Vartika Tiwari, Sarah Tahiri, and Rohan Kapri. So these are PhD students in the Khoury College of Computer Sciences at Northeastern University. Vartika, Sarah, and Rohan use R daily for their research, and I have full confidence that they will be able to help you as we work through all the topics today. Well, thank you so much, and welcome Ryan, Vartika, Sarah, and Rohan, and I hope that you will have a good experience.
Great. Thank you so much, Olga. Let me thank you for organizing such a great program here on computation, on proteomics, on mass spec data. I feel really fortunate to be able to be a part of this and really looking forward to sharing my experience with R with everybody here today. Just as a quick little bit of background, Olga sort of mentioned what I've been doing. I am a director of data science at Seer, and I use R every day. My team uses R every day, and it's really been a fundamental piece of how I work in my career. And I hope that we can, particularly for the beginners here, get you into using R and maybe seeing what a great tool R can be, and that can become a piece of your tool belt that you can use in your daily work. If you don't mind, I'd like to quickly give a plug here for Seer. We are hiring, and this is a great audience of people here. So I'd just like to quickly point out that we do have openings at Seer. If you visit us at our website, it's seer.bio. Check out our careers. We'd love to have people in the field that know about proteomics, that know about mass spec data. If you're interested or know people that are interested, it would be great. And please have a look there. All right, so let's get into the course. As you can imagine from the title, Introduction to R for Beginners, what we're trying to do is introduce R as a programming language to people that, one, probably don't know much about R, and also maybe don't know much about coding. And we're going to take it step by step. We're going to take it slowly, but hopefully by the end of the course, like Olga mentioned, that hopefully you'll be able to start using R to work on your own data. That's going to be our main goal here. So let me go to the next slide here and give you an overview of what we are going to try to accomplish here. So this is split up on 2 days. As you know, we're going to do about 3 hours each day here. Today, we're going to talk about really the fundamentals. We're going to talk about R as a programming language, and we're going to talk about a really important program called RStudio. This is going to allow us to essentially write our code, execute our code, and be able to work with R. We're going to go into some of the fundamentals about R as a programming language itself. So we're going to learn about some of the syntax, and hopefully, I wouldn't say this material is going to be dry, but it is going to be talking about sort of the fundamental background of R. What I'd like to suggest is, we're going to cover the main essentials, but hopefully if you can get through some of these main ideas and concepts, I think it will really take you really far into your journey about learning R. And in particular, towards the end of today, we're going to talk about a really important concept, and that's working with data tables. Essentially, most of the data that we work with come in the form of data tables, and we're going to talk about ways in which we can read that data into R and start working with it. On the second day, tomorrow, we're going to then continue what we learned on the first day here, and we're going to talk about a really important concept, this idea of tidy data, and talk about a way of working with R in a very sort of modern way, how we can do data analysis in sort of the modern way of working with R. And we're going to be talking about a set of packages known as the tidyverse, and in particular, talk about a package called dplyr that's going to allow us to do some really powerful data analysis concepts and ideas using syntax that is fairly straightforward to write and to read, and will allow you to really do some fundamental and powerful data analyses. Now, you probably heard lots of acronyms here. We're going to go into these things in more detail, so don't worry about that, but just want to give you an overview of what we're going to be covering. So again, sort of summarizes here what we're going to go over. We're going to talk about this RStudio program, how to use it to write and execute code. We're going to talk about some of the fundamentals of the language. Really importantly, we're going to learn about how we can read data into R. That's a really important piece. If you want to work with data, you need to get it into R. We'll figure out how to do that. And then move on to this idea of how we can work with data tables to do some data analysis, particularly with your own data. I think that'll really be an important goal that we'll try to get to by the end of this course. Before we get into the main topics, I wanted to give a little bit about background into R, and maybe give it a plug for why it's going to be worth your time and effort to learn R. First of all, you might ask the question about why should we use R? I know a lot of times when I do these workshops, people ask about why should I learn R versus Python versus maybe Java or another programming language. And to motivate that a little bit, I just want to get this idea that if we think about programming languages, there are programming languages that are more general in purpose. These are languages like C and C++, Java, and Python. These are known as general purpose programming languages. If you're a software developer, if you're going to write, applications, you're going to be writing web software, you're going to be writing, I don't know, video games, you're going to want to use a general purpose programming language. These languages are really designed to solve the general purpose of, making software. That's not a piece of that certainly is data analysis. And so, for example, Python is a great programming language for doing data analysis, but it's also very general purpose. R as a programming language is not a general purpose programming language. It was designed from the ground up to work with data, okay? And for us as scientists, we work with data. Probably one of the main reasons for us in our daily job that we'd want to use a programming language is because we want to work with data. And R was very specifically designed to do that. And that's why it's really great. And also, because R is designed to work with data, how it's developed, how it's designed and structured is informed by data. And so R is constantly evolving to make it easier to work with data. And that's really cool. That's why it really makes it a great language to learn. Believe it or not, even though R is focused in the data domain, it actually has become a top programming language. Certainly in data science, it's one of the top. I'd say, R and Python are two of the main programming languages for working with data. But in general, it also shows up occasionally on top programming lists in general, which is really cool. So there's obviously a lot of interest around R as a programming language. And then I think sort of the last point here, I think it's in this day and age in which we have so much data, particularly in the context of mass spectrometry and proteomics, where we have huge data files, I think all scientists should have some amount of skills in regards to programming to be able to just work with this data. Oftentimes, as Olga pointed out, Excel's not going to cut it. Doing analyses in Excel is okay, nothing wrong with that, but it limits the reproducibility of the work that you do. And in fact, you might be limited in the kinds of things that you can do if you simply focus on canned analysis packages like Excel. And so I think for scientists, R is really a great tool to learn. Let me say a few things about learning curves, because I think probably most people here are new to R, maybe new to programming. And sort of to motivate this a little bit, let's rewind, let's go 10 years ago, maybe even 20 years ago. Believe it or not, R has been around for 20 years since its v1.0 release. I think it celebrated its 20th birthday last year. So it has been around for quite a while. I first started using R, I'm going to date myself here, but about 20 years ago in graduate school. I was taking a class in biostatistics, and the teacher gave us an option about using a program to do our work and our homework. We could either use some statistics package, I think it was SPSS or some piece of software like that, or she introduced us to this. At the time, R was the new programming language. It had just come out. And we were able to use that for doing our homework, doing our work. And so I decided, yeah, let's give R a shot. Let me be honest with you, I didn't like it. It was a really weird kind of language. It was quirky. I felt like I didn't understand what it was doing all the time. And I felt like I was fighting against the language. I did get through the class, I did use R, but it never really felt natural. And to be honest with you, I set it aside. I didn't touch it for many years. When I got into my first job out of graduate school, my boss just so happened to use R. And so by default, I had to use R as well. So for the first couple months on the job, I really buckled down and tried to learn R and eventually got over that initial hump. And I frankly really fell in love with it and have been using R pretty much on a daily basis ever since then, just because it's such a great language for working with data. But like I said, at that time, it really felt difficult to learn just because there wasn't as much interest, there wasn't much of a community, there wasn't as much resources out there for learning R. I would say today, for all of us here today, is a really great time to learn R because data has become so important. We have this concept of data science now. We have whole programs that teach people about the area of data science. The data revolution has happened, big data, machine learning, all of these things. And because of that, R has really grown as a result. So we have a bunch of really high quality resources online for learning R. The tool itself has matured. And there's just lots of interest. There's been a really great community around the R programming language that has evolved. And whereas in the early days, it wasn't very friendly for beginners, nowadays it is really friendly. The R community in particular embraces new users. There are some resources I'll point you to at the end of the course where you can go for help about R. And the community is really welcoming. And it's just a really great community to be a part of. So for you here, I think it's going to be a lot easier to start learning R. That being said, it's still a challenge. Okay, it is going to take time. We're not going to become R experts, over the course of 2 days, a weekend workshop here. That's not realistic. You're going to have to put some time and additional effort in there, but I'd like to suggest that it's really worth it. I think once you get over this initial hump that I talked about, and it will be frustrating to start, once you get over that initial hump, I think you'll really start seeing how useful it can be in your daily work. And even if you don't become, you may not all be data scientists here. Some of you may work in the lab and so on, but I would like to suggest that sort of the ability of R to work with data can help even you, if you're just looking through some basic experimental data. Having this additional tool, I think, is really powerful. It will give you sort of an edge with other people, maybe, in your field, and you can also spread, what you know to other people to help, others get into programming as well. We are going to focus in this course very much on the essential basics of R. We're going to talk about using RStudio. We're going to talk about some of the language and the syntax, but I would like to note that there is a lot more to the R ecosystem that really provides additional benefits and power. If you have some experience with R, you may be familiar with a package known as ggplot2. If you haven't, definitely put this on your radar. ggplot2, in my opinion, and the opinion of a lot of other people, is one of the most powerful packages out there for plotting data, for making data visualizations in any language. It's a really amazing package. We're unfortunately not going to cover that here due to time, but this is something I'd highly recommend you learning about in your R journey. It's going to allow you to make amazing, powerful figures, for example, for publications or for your work. So it's a really great package. We are going to talk about this dplyr package. That's going to be the focus of our work tomorrow. This is a really powerful way for essentially analyzing data in this pipeline kind of structure. And it's really powerful. I think, I hope you'll really see the power and see how useful it could be in your own daily work. Very briefly here, there's another package called Shiny. You may have heard about this in R. If not, essentially Shiny is a framework that allows you to, using the R programming language, write interactive web applications based on data. I know in my own job and the people that I work with, we sometimes will make a web application that will present the data that we're analyzing to the rest of the people at our company. And Shiny is a really great way to do that using the R programming language. There's also another piece of R ecosystem known as R Markdown, talking about reproducible data science, reproducible reporting. R Markdown is a foundation for that. You can write reports. I use R Markdown every day in the work that I do. You can also use R Markdown to write blogs. You can use R Markdown to write books. It's really powerful. So R is more than just the language. There's all these other pieces around it. So when you learn R, you're learning, you sort of have this entry into this huge ecosystem that can be really useful for the work that you do in your daily job, either at school or at work. Let's talk a little bit of logistics here. We'll cover these things here, but let me just go over these again. As you know, the lectures will happen here in this main Zoom room. We're going to be covering some exercises as well. So I'm going to be mixing it up with some lectures and some hands-on exercises. We'll just stay in this main Zoom room and people can work in the background on their own computers. If you have any questions, I see some questions are popping up. I'll take a look here in just a minute. Please post them in the Q&A section there. The TAs will essentially try to answer those if they're, some things that they can just answer through texts. But if not, TAs can interrupt me and I can try to cover those things as live as well. I've been talking a lot and will be talking a lot, but I'll try to pause every so often to allow questions to come through. Please, in this virtual environment, it is difficult. I've taught lots of workshops over Zoom and it does work. I mean, this technology is great and we can do it. It does help to be live. It makes questions easier, but I would just encourage you, if you have questions, please reach out. I'd love for interactivity here. If you have questions about things, I'd love to be able to address those. That's what I'm here for and the TAs are here for. So please don't hesitate in asking questions. As you know, this link here, you probably got several times here. This links out to the main website here. In fact, let me just go there in my web browser here. TAs, is this large enough? Do you need me to zoom in? Is that viewable? Hopefully so. If you go to this main website here, you zoom down here to the sessions here, and if you go to the docs here, you've probably seen the Google Doc here, and the resources are here. In particular, I've linked out to a GitHub repository here. This is where all of the additional materials are also on the GitHub repository. Let me come to that right here. Okay, so this has the lecture slides. Let me zoom in a little bit here. This has the lecture slides that I'm going over here. So if you need to download those, go ahead and just download those right here. What you can do is you can just click on, sorry, let's go back to the main page. Click on the lecture slides link here, and then you can click on the day one and just click download here, and you can get the lecture slides that we're going to cover. Okay. Another piece that some of our exercises are also going to need some data. So come here to the data folder here and download this zip file, and then unzip this and then put this on your desktop, because we're going to be copying some data into some of our projects we're going to be working on. So just have this data ready to go. Hopefully, maybe you've already done this, but just pointing this out for people that haven't. I also had some pre-workshop setup materials. So hopefully you have a working version of RStudio, because we're going to be using that to work on. Hopefully you've downloaded RStudio, you've downloaded R, and you can see a window like this. If not, please go ahead and follow these instructions here. You're going to have to download R and the RStudio program, and then you'll be able to start working with us. Another alternative is working with RStudio Cloud. We have the link for that. You can talk to the TAs as well. Essentially, if you want to do this, this allows you to use R in the web browser through a pre-configured RStudio setup. You do have to create a free RStudio Cloud account first. So you'll have to go through that process. Once you do that, you can click on a link that the TAs can share in the chat, and then you can use that, and that will take you to a working version of RStudio. The data is already uploaded there. Essentially the environment is configured. So you can use this as, say, a last resort. If you haven't been able to get RStudio set up on your computer, you can try to use this RStudio Cloud instance to work with R. Okay, great. Let me now take a pause here and see if there's any questions from anybody about getting started. And TAs, please feel free to interrupt me at any time to answer stuff live. Great. Okay, so let's get into it now. Let's get into the main material. So the first piece that we're going to be doing is working with a program known as RStudio. So here's the goals here. We want to learn about what RStudio is and why it's important for our coding. We're going to learn some very basic ways about how we can type R expressions in R code within RStudio. And then we're going to touch on a really important piece here about RStudio projects. RStudio projects are essentially a way for you to organize the work that you're going to be doing. I'm going to suggest that you always use RStudio projects to organize your work. It also will help with other aspects of working with data in R in particular. And so from this piece, we're going to have the very fundamental basis of being able to start doing things with R. Okay, so first of all, what is RStudio? RStudio is known as an IDE. It's an integrated development environment. Think of this as essentially a program where you're going to write and execute R code. It does a lot more than that, but this provides the basis for doing work. One important piece here is that RStudio as a program is not the same thing as R. So you can't simply go to the RStudio website, download the program, and get working, because it's only the program that supports the R. You need to separately install R first, and then install RStudio. If you haven't done that, yet, if you go to the GitHub site, there is a pre-course setup that walks you through that process. And you can also maybe ping the TAs if you have any issues getting R or RStudio installed. You don't need to use RStudio to use with R. There's a variety of ways of using R. You can use, for example, if you want a command line or terminal interface into R, that's available for you, but I would highly recommend using RStudio. And I would say probably most people that use R on a daily basis use RStudio to work with R and use R. So it makes it a lot easier. One little note here just about terminology here is a little confusing, is RStudio is a program, but it's also developed by a company also called RStudio. So when you hear the term RStudio, it could mean, sort of both things. RStudio is a commercial company. They developed the RStudio IDE. There is a free version for us that we're going to be using, but just wanted to note those two usages of that term. Let me disambiguate things a little bit more as well. I sort of talked about this. So like I said, R is the programming language itself. It's developed by a core team of people as a piece of free and open source software. So this exists as its own thing. And really important, you need to install R first, as I mentioned. And if we kind of think about a metaphor, maybe an automotive metaphor, you can think about R is like the car's engine. It's the thing that makes the car do what a car does. We can compare that to RStudio. As I mentioned, this is a separate program, not developed by the core team that develops the R language itself. This is a separate company, also known as RStudio. As I mentioned, it has free versions. It also has paid versions. So if you work at a big company, you can get a paid version that provides support. For us that we're working here, the free version is essentially does all the stuff that the paid version does. So there's really no reason that we need to do that. And you install RStudio after you've installed the R programming language. In fact, if you install RStudio without having an R installation, RStudio will pop up a window that says, sorry, you need to install R, go do that first. So you really need to install R first. If we continue our metaphor about this automotive metaphor, you can think of the RStudio is like the body of the car or the interior. I mean, you could imagine some weird case where you have the car engine and wheels and you sort of can ride the car, but it's a lot nicer if you have maybe nice seats and a radio and air conditioning in the car. And that's kind of like RStudio. It makes the whole experience of working with R much easier. I mentioned RStudio Cloud. I'm mentioning it just because it's a neat way of working with R. You may want to consider using this for yourself. Essentially, you can use R through a web browser, which is really cool. It's full featured. It's the same RStudio experience that you would get on your desktop, except it goes through your browser. And so, if you're on an iPad or I guess even your phone, I haven't tried it before, but you could in theory work with R through the cloud version of RStudio. There's a free version there. You get something like 25 hours of sort of cloud resources for free per month. But it is a really cool option. And if you haven't installed R on your computer yet for this course, we have those options for using RStudio Cloud. Reach out to the TAs if you have any questions, and TAs, if there's any questions on that, feel free to let me know. Okay, let's get into RStudio. So hopefully everybody has installed RStudio at this point in R. And if you were to open up RStudio, this is what you get when it opens up. Okay, it looks, there's, obviously not very flashy. There are some windows here. We're going to talk about what these are. There's lots of text. There's lots of these tabs and all kinds of stuff going on here. Please don't get intimidated. We're going to walk through some of the main pieces here about what RStudio is and what we're going to focus on for this particular course. So let's see what we have to start with. This main window here that occupies pretty much the entire left side of the screen is known as the console. Okay, this is where you can type R code and execute R code. And I put down here interactively. We're going to talk about sort of two ways we can work with R code here. This is a way where you can immediately type code in, hit return, and execute that code. On the right side of the screen here, we have this pane here, which by default shows the environment. Don't worry about that for now, but as we work through some examples, you might want to glance over there every so often and kind of see what's happening over there. I think you might be able to figure out what's going on here. Down here on the lower right here, we have what's known as the file browser. This just is a browser into the file system on your computer. It kind of works like the Finder on the Mac, or what Windows Explorer on Windows. And that's how you can essentially navigate your file system and work with files there. There's another really important piece of RStudio that we need to get. And we'll do this live in here in just a second, and you're going to practice this momentarily. But if you go to File, New File, RScript, you're going to get a new window that pops up. Okay, and this thing is known as the editor. Okay, and this is also where you can type code. You can also execute R code from the editor. But what's really important here is this is where you are going to write code that you're going to save to a file or an R script. And I say in your daily work, you're going to want to save the code that you write. And so this is a great place for doing that. And so for this course, we're really going to focus on these two main windows here, the console and the editor. Okay. So now we're going to do our first practice session. As I mentioned, we're going to intersperse some lectures with some hands-on practice. And this is the first time to do this. This is also going to give people an opportunity to make sure that they have R installed properly and things are working. So here's what I'd like you to do. I'd like you to open up RStudio, and I'd like you to look around the interface like we just saw on the slides. I'd like you to try to create a new script and observe what happens when you do that. And I'd like you to try to identify which one's the console and which one is the editor, and how can you tell which is which. Okay, this is some basic stuff, but let's take, just a few minutes here. It's what, 8:30, or sorry, it's about half past the hour here. Let's take 2 or 3 minutes here to have people do that, and then we can walk through this live as well. So. Okay, Dimitri, let's see, asked a question. Let me answer this live here. Maybe one of the TAs can handle that. So Dimitri, how does R syntax differ from Python? They are different. They're both programming languages, so you're going to see lots of similar concepts. The idea of variables, variable assignment, the ideas of data structures like vectors, the ideas of things like for loops and so on, those exist in both languages, but the syntax does look a little bit different. In R, that is a little bit interesting and quirky in some ways. I'd say Python looks more like maybe some other traditional languages like, say, C or so on. R looks similar in certain regards, but it is a little bit different. And we are going to be looking at R syntax. So you'll be able to see that. So good question. If you haven't yet gotten R or RStudio installed, now's the time to do that, because we are going to be doing some hands-on exercises. So like I said, you can go to the GitHub website. Let me briefly step out of there. The GitHub website here, which is linked in the main materials. If you go down to the pre-workshop setup, we have some step-by-step instructions here about how to do that. Let's give it maybe one more minute here. All right. Fairly simple, hopefully, but so let me do this. Let me walk through this live with you here. So we're going to open RStudio. First of all, this is important. Is the text readable on the screen?
Yes, it looks good.
Thank you. Thank you. This is always hard because the default size of the RStudio is always too small. It's difficult to see, particularly on big screens. So, okay, good. If anybody has any issues or would like it bigger, just let me know. I can increase the size here. So this is what RStudio, like I said, looks like when you first open it up. Again, we're going to be paying attention more to the left side of the screen. And what I'd ask you to do is go to File, New File, RScript here, and watch what happens. Hopefully you saw this. This popped up a new panel here. By the way, if you go between these panes here, you can adjust the size here, so that's possible. And this is known as the editor. This is known as the console. You know this is the console because it actually is called console here. This doesn't have an editor, doesn't say editor here, but this allows you to type some code. And we are going to be typing some code in here in just a minute. But I just want to make sure everybody got to this point. So hopefully everybody made it that far. And feel free to post any questions if not. Okay, let's get back in here. Okay, so hopefully that was our first little practice session. We're gonna have lots more of these coming up. Okay, so let's talk a little bit about the console versus the editor and why you would want to work in one versus the other. So the console, that was the one on the bottom there. Think of this as a place where you can experiment, you can test, you can practice in the console. What you're going to do is you're going to type an R expression and hit return, and then you can see the results appear in the console. Okay, so it's really great for that kind of work. It's good for quick one-off coding. Maybe you want to test some of the stuff you're working on in your script. You're going to do that in the console. But please think of a console like I said a digital cocktail napkin or a sticky note. We know you write stuff on sticky notes, but those are subject to get thrown away at any point in time. You might lose those. So just make sure you understand that. You treat it that way. Just to sort of hammer that, this is transitory work. So just assume that anything in the console could be thrown away at any time. For example, maybe your computer crashes and you lost sort of those commands and scripts that you've written, and that may not be a good thing. The editor is where you're going to write the code that you want to keep. And for the most part, I would say that you're probably going to want to spend most of your time in the editor as you're working on a data analysis project. I'm going to show you how you can execute code from the editor. So it's not as though you can't run your code from the editor, but it allows you to save your work to an R script. And that's really important when you're doing data analysis. It makes more sense, even if you don't think you're going to want or need that code later, or you're just trying and practicing things. Sometimes it still is useful just to save them to the script. You can always go back and delete the stuff that you don't need or make a new script, but it's really useful to save the work that you do. Okay, so I would say in general, try to spend most of your time in the editor as opposed to the console. Okay, so we're going to focus on the editor and the console and be writing our code from there. But RStudio can do a lot more. And so there's a whole nother universe you can dig into as you get more experience with R. So there's a whole bunch of keyboard shortcuts, which are great. As you get more experience with R, you can use the keyboard shortcuts, and that will really streamline your process. There's a debugger that is certainly more complex to use, but if you're writing some code and it's not working as you expect, you can use a debugger to help you understand that. And there's also code snippets. There are ways to invoke these things through keyboard shortcuts that will pop up templates of code that you might use over and over again. So really cool. There are add-ons you can download, lots of stuff there. Another important thing is using version control systems. So if you're new to coding, you may not really know much about this, but one of the fundamental pieces of doing reproducible work is to be able to keep track of the code that you write and keep track of how it changes as you write the code. And one way to do that is using a version control system. Git is one of those systems. And actually, I'm using that for the materials for this course through a GitHub repository. Again, that goes beyond the scope of what we're going to cover here, but just letting you know that RStudio does integrate with that really nicely. That allows you to work with those systems from the application. I talked about all these other things. I talked about R Markdown and Shiny, briefly mentioned those. RStudio helps you work with those things. And RStudio is always evolving. They're releasing new features and functionalities that really helps working with data analysis workflows. So great program, a lot there. We're just going to scratch the surface today, but there's a lot more to work with. Okay, so that was kind of our really first basic system into using RStudio. Let me pause just for a second to see if there's any questions about RStudio. Okay, great. Now let's get into some really basic coding in RStudio. We're going to cover the syntax in more detail in the next section, but I want to get you started about writing code. And this is something that's really kind of different. I remember I was teaching a workshop many years ago, and there was somebody there who was very new, and his comment to me afterwards is, Ryan, I like the workshop, but I didn't get all this stuff. Where I'm used to working in Excel, where I have an interface where I can, put my data in there and I can click on menus and buttons. And here we're just writing all this code. It was very foreign to me. And so I wanted to spend a little bit more time with him to talk about what that is. So I want to talk about how we actually get things done in R versus how we get things done in other languages, other tools. So let's talk about Excel. We probably all have used Excel. This is a graphical program, a GUI, a graphic user interface type programming. And in Excel, in a great program, let me not say anything bad about Excel. I think it's a really amazing tool. I use Excel, a lot in my work, but it is a certain tool useful for certain cases here. In Excel, you do a lot of your work by pointing and clicking. Okay, you use the menus to do things and select cell ranges and so on. So a lot of your work has to do with pointing and clicking. In R and in RStudio, you do a lot of your work by typing. Effectively, everything you do in R is embodied by writing code. You're going to be writing expression as texts, and that encapsulates everything that you're going to do. So imagine a workflow that in Excel where you are maybe filling some data in and selecting cells with your mouse, and then selecting a menu option from the menu bar and selecting make a plot or something. All of that, those steps get encapsulated in code. So that's really a fundamental thing to understand, that everything in R comes through code that you're going to write. And this really has some important advantages. Okay, it may not, particularly if you're working in a GUI-based environment, you may think writing in code, typing things out, boy, that's going to take so much longer. It's much easier for me just to point and click things. That makes it more understandable about what I'm doing. But it turns out that writing code in scripts is really important. And one of those key things has to do with reproducibility of data analysis. Code explicitly captures what you do. So if you take a script that goes and reads some data and does an analysis, every part of the process is inside of that script. And again, let's compare that to Excel. If you wanted to make an Excel workflow reproducible, you would have to maybe write down in a document or even record yourself in a video, clicking all of the buttons and interface menus that you did to get to a particular kind of analysis. And that is much more difficult to reproduce and can be error prone and so on. So it's really nice that if you capture everything explicitly in code, everything has a record of what you did. It's also easier to share with others. It's really common, among my team, and frankly, any team that works with data. If you want to share an analysis, you just send them a script that did everything. And it's really simple. All they have to do is go and run that themselves. It's much more difficult to do that with a GUI-based software package. Let me touch upon this point here about reproducibility, and that's what Olga mentioned at the beginning. Code enables reproducibility. It also enables you to do anything you want. I put anything in quotes because there's obviously limits, but if you're using a canned software package, and let's think about some of the software packages that are provided by mass spec instrument vendors. They have software tools for analyzing mass spec data, which is great, and those can be really powerful, but you are essentially locked in to the methods and the analyses and the ways of doing things that they've decided to program into their program. And so let's say you wanted to change the way in which you maybe normalize your data, or maybe you want to try a new statistical method that hasn't been implemented in any piece of software. You're not going to be able to do that through canned programs, but R gives you the flexibility to do that. And believe it or not, coding can be faster. I know it might seem that being able to just click some menus real quick and hit Enter might allow you to do analysis faster, but actually, when you get used to R and more into the language and understanding how to use it, coding can actually be a lot faster. You can type out some lines of code really quickly to do complex analyses that might actually take longer to do in a GUI environment. Okay, so we are about ready to start typing some of our first lines of code, and we're going to start this motivation for a calculator. So R can be used like a calculator. It can be used much more than that, but we can use it like a calculator, and we can do any basic kinds of operations. So we can write an expression 1 + 1 in our code and hit return, and we will add those two numbers together and get the result out. So we're going to do that in just a minute here. We're going to be talking about what's known as base R. We're also going to be talking about another sort of part of R that has to do with packages here, but base R provides lots of fundamental functions. So for example, if you want to compute the mean of a list of numbers, there is what's known as a function that allows you to do that. There's functions that allow you to calculate the standard deviations and medians. There are functions that allow you to do linear regressions, all kinds of stuff. And this is all baked into R. And so you're able to do some of these simple and perhaps not so simple calculations using these base functions in R. And we're going to see some of those here in a little bit. There's also specialized packages out there that you can download and install. In fact, we're going to hear about amazing packages here as part of the main institute that Olga and her team developed, MSStats, for example, that are powerful packages that are add-ons to R that provide additional features here. And just to give you an example here, there is a repository where these official packages live. One of those is known as CRAN, another is Bioconductor, which Olga mentioned. But on CRAN, for example, there's more than 10,000 packages on there. So if you are looking to do something, there may be a package out there that can address your needs. If you're interested in mass spec proteomics, you probably want to go to Bioconductor, and there's lots of amazing packages there. If you're interested in analyzing, stock data, there are packages in R for analyzing stock data, all kinds of stuff there. So there's lots of stuff there that can give you more functionality into R. And what's really cool about a programming language is you can write your own functions. We're not going to specifically talk about that in this class, but with more experience, you can write your own functions to essentially do anything you want, which is really cool. Okay, we're going to, before we write some code here, or just some quick tips, I'll cover these live as well, but in the console, you're going to be typing expressions and executing them. If you press the up arrow at the console, you can cycle through those commands. It holds a history of what you did. So if you push the up arrow, you can go back to previously executed commands. That's really useful. You can also use standard sort of text editor commands. If you work in Word, for example, you might use some commands like using the arrow keys and Command and Shift to select words and text. You can typically use those same keyboard shortcuts in RStudio as well. If you ever get into problems in the console, and I'll show you some examples of that happens, press escape to abort an expression. It kind of gets you out of some troublesome situations. We'll be looking at one of those in one of the examples here, but just know if things are working really weird in the console, press escape to kind of get out of there. In the editor, you can see that the line numbers are numbered on the left side, so you can keep track of what you're working on. Again, you can use standard text editor keyboard shortcuts. And also really useful, and I'll demo this live here in just a minute, you can push Command or Control return on any line of code in the editor, and it's going to go and execute that in the console. We'll cover that live. You'll see why that's really important in just a minute. Okay, so practice time. This is going to be our second practice time. What I want you to do is go back to RStudio. I want you to create a new script. We learned how to do that before. And I want you to type some math expressions in the console. What do I mean by that? I want you to type 1 + 1 and hit return. Okay, you can do multiplication, which is the star symbol. You can do division, which is the slash, and so on. So just do some basic math expressions. I want you to do that in the console, and then I want you to try doing that in the editor. And I want you to sort of take a look at how those two modes of interaction with R are similar and different. So let me give you maybe just a few minutes here, and then we'll cover this live here. And please, any questions about this so far, please feel free to post those in the QA, and we'll cover those. So let's take, 2 or 3 minutes here to try writing some basic math expressions in the RStudio terminal and console. So good. Okay, so great question. I'll cover this live though. So somebody said, how do we execute in the editor? By hitting enter or clicking run? Great question. And I kind of briefly mentioned that, but not in any detail there. And we're going to cover this live. But if we come back a slide here, in the editor, if you put your cursor over a line of code and you push, if you're on the Mac, Command Return or Control Return, it will execute that line in the console down below. So give that a shot. There's also a way in the interface, which I'll show you, that can help you run a line of code or run the entire script. So Jessica, you had asked about typing in the editor. So the first thing you need to do is make sure that you create a new R script, because the editor won't show up until you create a new R script. So do that from the menu. File, new R script, file new R script, and that will pop up a new editor window there. Great. Okay. Somebody just asked a question. In the console, 1 + 1 returns 2. In the editor, it says 1 + 1. Great. So let's hold that question, and we'll cover that live here in just a minute. All right. So let's take a look. Let's go back to RStudio here. Let me close. I'm going to close RStudio so we can get back to what it looks like from the beginning, just to recover this. Right, so this is what RStudio looks like when we first open. So one question is, how do we get in the editor? Again, it's not showing up here. This is the console here. This is not the editor. So what we actually have to do is we have to go into File, New R scripts. Okay, and that's where this new editor will show up here, this editor window. All right. Again, if you want to change how big these are, you can drag the little drag bars between here. You can also do that here on the vertical bars here as well. Okay, so let's take a look. Let's do our first R expression here. Let's do 1 + 1, and let's hit return. We executed the expression here. Let me walk through what we have here. So here's the answer to, that's what we expect. Notice that there's this weird bracket and a 1 here on the left side. This is not part of our answer. Okay, this is just some output that R is providing to us. Essentially, it says this is the first item of a long list of items here. You could imagine sometimes your answer has lots of sort of answers to it. If you're, and we'll see what this looks like in a little bit, where we work with vectors, where we're going to have doing math on multiple numbers at the same time. This one just helps us number and say this is the first item here, there. And if we had multiple lines of answers here, this number would increment to know kind of what number answer is on there. So just for all intents and purposes, ignore this bracket number sign here. And this is the answer that we have here. Let's type this in the editor here. So 1 + 1. Okay, and we can just sit here, and we can sit here as long as we want. Nothing is actually going to happen, because now this is just a text expression here. We haven't done anything with it. Okay, if we want to execute it though, there's a couple ways we can do. We can click this run button. So let's do that. So let's watch this cursor. See the cursor blinking here? Let's click run again. Let's look down here at what happens in the console. When we click run, it executed that line of code here. It essentially retyped that expression for us and executed it to get to the answer out. Okay, so that's one way you can do the script. write an expression. Another way is just put your cursor on the line that you want to execute. And I'm on a Mac, so I'm going to hit Command Return. If you're on a PC, you hit Control Return, I believe. And let's see what happens here. So if you watch down here in the console, it essentially retyped that expression again and executed this line of code down here in the console. Okay, so we could do that as well. Let's do something else. 3 times 12. Again, nothing's going to happen here until we hit Command Enter, and then that will execute that expression down here. Okay. Again, we could also just put our cursor here and click Run here, and it will run that line of code for us. There is another button here I'll just mention here that's called Source. Let's click this button and see what happens. Actually, I'm going to clear this console out here by clicking this little broom button here. Okay, that just clears the screen there. Let's see what happens when I click Source. This actually just ran this document. We didn't do anything here aside from running these expressions, so you didn't see anything, but we're going to have some variables here that we're going to talk about a little bit. It would have executed that. Effectively, what the source does is going to run all of the lines of code in your script. Okay, so we'll see that in a little bit. But again, you can click the Run button, or you can put the Command or Control Return to execute those expressions. Great. Okay, any problems or questions there? I know we're starting kind of slow. We're taking this really step-by-step pieces, but I just want to build on this foundation to make sure people can write our expressions. We are going to get more complex things here in the next session. Great. Let me pause here just for a second to see if anybody has any questions or any problems. Again, please reach out on the Q&A if you have any issues. All right.
Ryan, someone
Yes.
wants you to explain source again.
Okay, I'm sorry. Yeah, it probably will work better in other contexts here. Source, what it does is going to go through and run all of the lines in your script here. In this case, we're not actually doing anything per se. We're not saving any variables. We're not making any plots, anything like that. And so when I click source here, it actually, we don't have any visible output here in the output console here. But as you get more complex scripts, imagine you put a script together that does a bunch of stuff. It reads a data file, it does some data analysis, it makes a plot at the end. If you want to run that entire script, you can click the source button. It'll go through and run that script line by line for you. Okay, so mostly just a note for your future analyses here. It's not as useful here when we're trying to just run some interactive expressions here. So run makes more sense in this context. Great question.
Ryan, can you also please talk about the space in R, like 1 + 1? If you don't put any space, it will produce the same result as if you put space between the plus and the 1.
I love that question. That's a great question. And the answer is a bit complex. Sometimes spaces are absolutely essential, and sometimes they're not. And I'll talk about that particularly when we talk about variable assignment. I'll be talking about that kind of more generally. This is a part of the language, as you learn, about when spaces are needed and when they're not, when they're optional, when they're not. In the case of a math expression like 1 + 1, it doesn't matter if you put a space between the numbers and the operators. It's the same thing. So 1 + 1 is the same as 1 space 1 + 1, put spaces there. You could put a bunch of spaces here if you wanted to. I don't recommend it, but you can still execute this and it still works. Okay. What spaces do though, particularly when they're optional, is in my mind, it helps your code breathe. Okay. If you mash everything together, at least for me visually, it's a little more difficult for me to read. And I think maybe others would maybe agree with that. If you can put spaces around your operators like this, it helps your code breathe. And it helps it, in my mind, make it more readable. So in this case, the spaces are optional, but I would suggest using them because it makes it more readable. That being said, again, let me say that spaces sometimes really matter and sometimes they don't. And that's just part of learning the language. We'll cover some of that. If you have questions about spaces, please bring them up. But we will be talking about this in more detail. Okay, great. Thank you. Great questions. Really good questions. These are exactly the kind of questions I want to be able to answer. These weird things about programming. A lot of programming are these weird conventions about how to write code correctly. They're just rules that people made up somewhere. And so you kind of just need to learn those rules at some point. But these are exactly the kinds of questions that are great to answer. So please keep those kinds of questions coming. Don't feel like, these things are stupid questions. They're absolutely not. They're great questions. So, okay. Okay, what can we do right now? We can open up RStudio. We know about the console. We know about the editor. We can type some code. We can execute some code. Okay, we're going to talk about code, but brief detour, we need to talk now about RStudio projects. We are setting up the foundation that's going to allow us to work on analysis projects. And a really important piece of this is this idea of RStudio projects. RStudio as a program helps us work with R. Then there is a feature within RStudio known as RStudio projects, which further streamlines our workflows. Essentially, you can think of RStudio projects as simply just a directory on your computer. So you probably do this already, or hopefully you do. When you're working on a project, maybe for school or for work, you probably use a directory structure where you maybe try to organize your files together in a central place based upon the different projects you're working on. An RStudio project has the same idea here. They're essentially just special directories that help you organize your work, okay? The key piece of RStudio projects is they help you deal with file paths. What do I mean by file paths? We're going to talk about this explicitly when we talk about loading data into R, but effectively, file paths are the way in which we tell R where pieces of code, where pieces of data live on our computer. And that can surprisingly be a frustrating process sometime. And RStudios help make this whole process a lot easier. And so that's really one of the key things. One, it helps you organize, and two, it helps you deal with file paths. I've taught workshops like this in R, and there'll be multi-day workshops, and people still struggle. This is a common thing. They'll still struggle with file paths even after, say, multiple days of going through this stuff. So don't feel bad if this stuff is a little bit difficult to work with. RStudio projects will help you get over this particular frustrating point about R. So here's the idea. Here's how I'm going to suggest and ask that you work with RStudio projects. One, you have to make the project. I'll show you how to do that. But once you've made the project, again, it's really just a special directory. I want you to place all of the files for your project, your analysis project that you're going to work from. All of the files, your input data, your scripts, everything are going to go inside of this directory. Okay. And by doing that, you're going to be able to access those things very straightforwardly, directly by their name. Okay, you don't need to get more fancy about how you specify these things. You can just use the file names. If you want to get back to your project, there's a special file hiding inside of the RStudio project called the rproj file, the .rproj file. We'll see that. All you have to do is you go to your file browser. You're just going to double click this file. It will launch RStudio for you. It will bring up your project and how it was in its last state, and importantly, set up what's known as the working directory for you, again, to help deal with this nagging problem of working with files on your file system. In the slides, we're going to cover this live. It's much easier to do this live here. In the slides here, I have a set of slides here that walk you through the process of making an RStudio project. Please refer to those, after the course here if you want to walk through it. It's a fairly straightforward process, but it does take some steps to do, and there are some things to consider. So all these are in the slides, but I'd like to cover this live here for you. So let me go back to R. Let's close it. By the way, if you wanted to save your script here, you can click on the file icon here and save your script to, out to your file system. Again, the important part about saving your work, you can do it here by clicking the save icon. And if you close it without saving it, we'll ask you if you want to save it. Okay, let's click on RStudio. And actually RStudio did kind of remember that I still had a file here. So I'll get rid of that. We don't want that. Don't need that anymore. What we're going to do, and again, this is covered in the slides step by step. Remind me later, that's fine. Step by step, this is going to be covered in the slide. So you're going to go to File, New Project. And then we're going to have this little project wizard that's going to walk us through the process of making a new RStudio project. And sometimes, for whatever reason, RStudio likes to think about things. I'm not sure why that's the case, but anyway, sometimes you have to give it a little bit of time here. What we're going to do is we're going to make a new directory. Remember, an RStudio project is just a directory. So we're going to make a new directory. Then we have to, for some reason, yet again, say that we want to make a new project. Two or several main things here. First of all, we want to say where we want to stick this directory. So we can have a standard file browser here, like any other kind of program here where you can navigate the file browser to make a project. In this case, I'm just going to stick it on my desktop because it's easy to see and work with. And let's do a May test, for example. This can be anything. This is what you want to name your project. Doesn't matter what it is. It's just the name of the directory. Okay. And what we need to do then after that is create the project. I want you to watch over here on my desktop here. What happens when we create this project? You'll notice that a new directory popped up on my desktop. So it made a directory for us. RStudio is kind of blinking out here and refreshing itself because it is now setting up our environment for working in this project. We didn't talk too much about here. This is about the file browser. If you look at sort of the information that it tells us here, the file browser has now switched directories to be inside of this folder here. Okay, so this is our RStudio project. And remember, we have this RStudio project file here. So let's do the following. Let's go to File, New R script. And let's do some basic math. Let's do our famous 1 + 1 calculation here. Let's save this as a script. So I'm going to, you can click the file icon here or click Command Save to save the script. And let's call this our test script. Notice that it's already set us up for the directory is our testing directory that we just made. It set that up for us and we can click Save. And you can see that R script appeared over here in the file browser. If we wanted to get back to the R script, we can simply click on that file here and it will open it back up with our work and our work is saved there. Let me show you this other scenario where you are done for work for the day. You've gone home, you come back the next morning and you want to pick up your project. Let's close RStudio. All you need to do is go back to the folder where your RStudio project lived and double click on this RStudio project file. And give it a little bit, but you can see it's going to launch RStudio for us. And it is going to move the directory over here to the project. And if we want to get back to our script, we can simply click on that R file and it's right here to continue working. All right.
Brian, someone asked the question about whether we can save files in our project, and you just covered that. But I think one thing that we can point out here is that while typing in our script, we can often we can have the habit of pressing Command S or just manually save it.
Great, I love that. I love that tip. Does anybody? I am a habitual saver when I'm making Word documents or Excel, PowerPoint. I have this muscle memory of doing Command S, on the Mac, Control S on Windows, of essentially saving my work here. So that's a great question. That's maybe a great habit to get into here. That same kind of workflow applies here in R. So again, a couple things. I put some extra spaces in here. Notice the file name turned red and there's a little star there. That informs us that we have not saved this document. Okay, so now I am going to press Command S. You can't see that, but I'm going to do that. When I do that, you can see this goes back to black and we have now saved this file here. So that's a great tip. As you're working on your script, it's great to get into a habit of pushing Command or Control S to save your file so you don't lose that work. So great question. Okay. Anything else on RStudio project? I see some questions here. Maybe the TAs can cover some of those, but anything we want to cover with the team?
There's a question about what's the mean of use RENV with this project?
Okay, let me go back there. Get back to that window here. So I think you're referring to these options here, is what I guess they're referring to. Let me cover them both. This, remember I talked about version control a couple slides back. This is about tracking versions of your code. RStudio has the ability to interact with a version control system like Git, like GitHub. If you click this button, this will allow you to do that. That's a little bit beyond the scope of what we're going to talk about here today, but just let you know that's an option. The question here asks about use renv with this project. Let me just very briefly say, again, this is another option that we're not going to cover and you probably don't need right now, but renv is a package that allows you to manage versions of other R packages in a reproducible way. You can imagine as code gets updated, there will be new versions of code. And if you ran your analysis last year, you likely used different versions of packages and code than what may be available this year. And so if you ran code from a year ago on packages that were made today, you might get different results because the versions have changed. Okay, and that can be a problem for reproducibility. So this renv is a package that effectively allows you to version control your packages themselves. Okay, so again, those are sort of more advanced topics. You do not really need those for your particular use cases for now as a beginning student into R, so you can just safely ignore those. This open a new R session, you don't really need to worry about that either. It kind of takes care of that. So really you just need the location of where you want to stick your project and the name of the directory, and then click create project. All right. Let's go back to the slides here. Okay. So I have a practice session here. We covered this live a little bit, but I would like for you to practice. And we're going to need two main pieces here. One, the material I just covered about creating a new project. I want you to go and do this for yourself in your own version of R. And then I want you to kind of work through this stuff, just note where the R projects file. But the main thing is I want you to copy one of the data sets that we're going to be working with here into your project directory. Okay, where does that data live? Hopefully you already have this. If you don't, no big deal. I want you to go to the GitHub repository. Maybe TAs, you can quickly repost the link for the repository into the chat. All you need to do is go to this website here for the repository, go to data, click on the exercise data.zip link here, and click download. I've already done that. Let me redo this here. It's going to download the file, and then I'll just replace it here. So you're going to download this data, you want to unzip the file, and inside of this directory, you're going to see two files here. We're working with the one that has annotation. This file is a lot smaller than the other. The other one is quite big. It's almost 200 megabytes. So let's not deal with that now. You're going to use this annotations file. So this is the file that I want you to use for this particular hands-on section. Okay. If you have any questions, go ahead and ask them in the QA about finding that file. But again, it's on the GitHub site. So here's what I'd like you to do. Let's spend a few moments to do this exercise. There was one question about RAM requirements for R, which is a great question. I think I'm going to cover this maybe tomorrow a little bit. R tends to be very memory hungry, uses a lot of RAM. So the simple question to this, and maybe the unsatisfactory answer to this question, is as much RAM as you can get. If your data set is really big, you can get more RAM to help deal with this. I typically, at the very least, when I buy laptops, I want at least 16 gigabytes of RAM. At a bare minimum, would certainly love to have 32 gigabytes of RAM. And, more can be helpful, particularly if you have really big data sets here. So that's kind of the short answer, as much as you can get. 16 gigabytes is, in my opinion, sort of the absolute minimum I'd want to have for typically sized data sets. That being said, if you have a really big mass spec data set, you may have files that could potentially be bigger than that, in which case it could be a problem. See, there was a question about guess max. I think probably somebody is looking in some of the examples, which is great. Let's see, I will cover that later, but effectively the guess max is a way in which the code that is trying to read the file is trying to guess what kind of types of data are in that file, and guess max is the argument that asks how many lines I want to use in order to guess what kind of data is there. It's a little bit complex. I'll cover that though at the end of actually today when we have some exercises. Okay, so the question is, when we do this, great, I didn't really say this. So read CSV. You could write this in the console. You could also write it in the editor and then execute the line of code like we showed, where you can put your cursor over the line of code and click the run button, I think, or you can push Command or Control Enter. So either way works. There's no best way to do that. Maybe if we're going to practice working in the editor, type it in the editor and execute it from there. There's a question about how to copy the file into the project directory. You can do that using the file system on your computer. So what I'll cover that live here in just a minute here, but literally you can drag and drop that file using your default computer browser. And then the last piece here is essentially close RStudio. I want you to be able to get back to your work just by simply double clicking the R project file. So fairly simple to do, but just want to make sure you're aware of that. Let's give it maybe another 30 seconds here, and then I'll cover this live.
There's an interesting question about whether there is a shortcut to read CSV files instead of writing the long name of the files.
Great, I love it. Let's save that question because there is in RStudio, and we can use the power of RStudio to help with that. Great question. We'll cover that in just a minute. Thank you. All right, if anybody is still working on this, just recall that all these sort of little practice sessions are in the slides, and feel free, you can practice these also later afterwards. And obviously cover any questions at the end as well. Let's go into RStudio and let's actually do this here. Let's start from the beginning here. I keep closing RStudio, doing that so we can have a fresh session here. Let's bring up RStudio. My computer is running slow. I think it's time for me to get a new laptop with lots of RAM here. Okay, let's do this. So again, we're going to create a project. We learned how to do that. We're going to go to File, New Project. And I recommend, if you're going to go work in R, this is the workflow I'm suggesting that you do. You're going to do a new project. You're going to open R up. You're going to make a new RStudio project. We're going to do a new directory, a new project. Let's just call this test for now. We'll make it separate from the one that we had. We're going to put this on the desktop and we're going to create the project. You see R is setting itself up now to work with this RStudio project. great question. How do we get that data into the into this project? Well, again, remember the project is just a directory here. So you should be able to see it on your file system, just like normal. You can double click on it and bring up the contents. So no problems there. If we want to get that data into the project, we can open that exercise data directory that we downloaded from the website. I'm going to click on this file. I'm going to do a copy here, Command C. And we can even just drag it over here as well if we want, however you want to do it. But this is outside of RStudio. Okay, so nothing about RStudio here. We're literally just using the file system on our computer to get this file into our project. Okay, and if we look over here now, we can see that this file now appears in our project here, which is cool. Okay, and then the next thing I wanted you to do is read this file into R. And so we're going to use this function. And frankly, you could just copy and paste this code because we really haven't gone over the details here. We will do that shortly, but you can copy and paste that code. I'm just going to type it here, read.csv, put this opening parentheses. Now to the question that was just asked, how can we sort of get to this file without typing all the code? Here's what I'm going to do. I'm going to tell you what I'm typing. I'm going to type a double quotation mark here. Okay, and RStudio did some interesting things here. Notice that it also, I just pushed that button once, the double quotation mark, but it actually put another one for us in there because we want, this is called quoting a file. We'll talk a little bit about this in a bit, but we want to quote this file name. And if we start typing the name of the file, capital C, H, if we push the tab key on our computer, it will complete the whole thing for us. We didn't have to type the whole thing. So essentially what we did was we started typing the name of the file. Let me get rid of that actually. We started typing the name of the file. And then if we push tab, it will complete the rest. Okay, if there were multiple files that started with CH in there and we hit tab, it would give us an option to select additional files that we could then use our arrow keys to select from and hit return. But again, if you just first start typing the file and press the tab key, it should auto-complete for you, which is really cool. It helps you prevent saving, essentially making typos here. Okay, so let's run this. And great, we read the file in, it spit it out to the line. We're going to talk about using variables, but effectively it read this file in for us. Okay.
So Ryan, now that you read the data with the double quotation mark, there's a question that is there a difference between double quotation and a single one?
Yeah, so for all intents and purposes, let's say no. You might use them in different contexts, and particularly it's if you want to get quotes, single quotes or double quotes into a particular expression. A little bit of details there, but let's, for most intents and purposes, it doesn't matter. And so let's do a single quote here and let's type CH and push tab. You notice that it auto-completed the entire thing. And if we hit return, we can read the file the same way. So double quotes and single quotes don't matter too much. I guess I tend to use double quotes. It's just kind of what I'm used to using. I think in Python, I think lots of people use single quotes sometimes. In this case, it doesn't matter. So either work just fine. Great question. Okay, let's do, let's see, I think I have some other exercises here that's going to explore this a little bit more. Whoops, let me get rid of that. Okay, basics about working with R. We're going to revisit reading files and what happens if this file wasn't there, what happens if we misspell something. So we're going to investigate that in a separate section about sort of reading files in more detail. So we'll get to that in a little bit. Okay, so any questions now about making RStudio projects and getting files into the project?
Somebody got lost how to import file.
Okay, right. So let me go back to that. So so first of all, you need to create the RStudio project, and we have slides in the, and we've gone through that about how to create the project. Once you create the project, essentially what it's going to do is make a directory on your computer, okay? And there's really nothing special about this directory. This is like any other directory on your computer. So you can use your file web browser, for example, to go to the desktop where this file lives and go to that directory. to get files into this folder. Again, this is outside of RStudio, so nothing to do with RStudio. You can just take any file you have on your computer, like you would do with any other kind of program, and drag and drop, for example, or copy and paste a file from another location into the project directory. So we're going to use the file system to do that. Does that make sense? Again, this is outside of RStudio, just using the capabilities of your computer to get files into this special directory. All right, great. Okay, so we have, maybe we'll take a little 5-minute break here. People can, we've been going for about an hour here. We'll take a 5-minute break. People can maybe refill their coffee, maybe take a bio break here. What have we done though in this first hour? We've effectively learned about RStudio, what it is. We've learned about how we can type and execute code in either the console or the editor. We've talked about making RStudio projects and how we can get sort of data into these projects and start working with that. So that's the main foundation. In the next section here, we're actually going to start talking about the R syntax itself and actually start writing some code to do some interesting things with data in R. Let's see, it is 25 past the hour. Let's come back at, depending on your time zone, for me, it's 9:25. Let's come back at 9:30 or in 5 minutes from whatever your time zone is, and we'll get back into it. Feel free to continue asking questions, but maybe go refill your coffee or your tea, and we will come back in 5 minutes. Thank you. Lee, if you're still around, you had asked a question about when I close R and restart R, it comes back to your open project. How do I close it out? That's a great question. Let me cover that. That's kind of a little, maybe a useful thing that RStudio is trying to do. It's trying to get you back into the last thing that you were working on. Let me open up my test project that I had made. Remember, you can double click this .r project file, and that will start up your R directory. If you want to close down the project, come to File, Close Project. Okay, so that will close your project out. You'll see that R will, let's see here, got a little small here. It'll close out R. It'll sort of reset here like it's trying to do here on my computer. And you will now be back to R in its kind of original state, and we're no longer working in that specific project. Okay, so again, that's File, Close Project. Thanks, Timothy. Great question. Experiment about using R programming in industry. Are there any formalities that academics might not use that you have? Great question. And I think things are getting a lot better in education in general, in academia, in schools, just because data has become so important. We're getting better programs that really understand the technologies and the key pieces. I would say if I were to make a differentiation, industry tends, I think, to be a little more careful about reproducibility, about, you'll hear terms like production level code, these kinds of things. And so, there might be more rigor placed upon writing code that's correct, writing code that's reproducible, writing code and pipelines, analysis pipelines that can be traced from beginning to end. We use version control systems like Git a lot to track our code base and how it changes over time. You might do things like code reviews with other people at your company, again, to make sure that the code is doing what you expect, to find bugs and so on. So I think, there might be a little higher level of rigor that you will see in industry that you don't see as often in academia. Like I said, things are definitely getting better. But certainly when you go into industry, there's going to be more emphasis on that kind of thing. Also because you're going to be sharing your code. A lot of times in industry, or sorry, in academia, you might be the solo person working on your project, and you're free to work with how you want and can kind of do whatever you want, and nobody's looking over your shoulder about how you organize your files and so on, how you write your scripts, and frankly may not even look at your code. In industry, that's not the case. You're probably going to be working in a team. You're going to be sharing code with others, in which case all of these sort of foundations and mechanisms about working with R, doing it reproducibly, doing it in a rigorous, high quality way, I think really comes to the forefront. So I think that is really kind of a key difference that you might see. Hopefully that answered the question. So here's a question about having few scripts. Is there an easy way to transfer the scripts and data sets into a new project? Yeah, so one easy way, like I said, you literally, again, these are just folders, so there's no reason you can't just drag and drop or copy scripts from one folder to another to an RStudio project. So again, you can just do that. There is an option in RStudio. I won't go through it. I'm happy to cover it maybe at the end if you'd like, but you can make a new project from an existing directory. So if you already have a directory that you've been working out of, but you haven't deemed that as an official RStudio project, you can use the interface and say, instead of making a new directory, I want you to use an existing directory. You navigate to that directory on your file system, and then it will sort of convert that directory into an RStudio project. So that's another way you can do that. All right, here, maybe in the interest of time, we'll keep going here. Let's go back to our slides. Thank you. These are all great questions. Thanks for posting them. So we have, like I mentioned before the break, we have the foundations for using RStudio. We have the very basic foundations for writing and executing code. Now let's learn about some of the fundamentals of the language that will allow us to do this. Okay, so this is our very first steps with R coding. And goals for this module is we want to understand how to work with R the basic way and how you can use it to do things. We're going to talk about syntax. I'll tell you what syntax is, but we're going to learn about sort of the essential R syntax. We're not going to cover all of R. There's no way we can do that in in these sessions here. They're just too short, but we're going to be covering the essentials that I think are really important to get started with. We're going to talk about this idea of data structures in terms of variables, which can hold our data, as well as things like vectors, which hold collections of data. We're going to talk about also this really important context examples of conditional expressions. This is a really important piece of working with data. And then we're going to cover some essential functions. I talked about some of the functions like being able to compute the mean on a set of values and so on. We're going to talk about some of these fundamental functions that you can use in your daily work and analysis. Okay, so the first thing we need to talk about is R syntax. And what is syntax? Effectively, these are the rules that define how you write correct R code. Okay, so human language, our spoken and written languages, we have some flexibility in there. For example, you can communicate to others. You might have an accent or you might pronounce things a little bit differently, but oftentimes we can communicate even though we have some differences in the ways in which we communicate. Our written and spoken languages have some flexibility there. This is generally not the case for programming languages. Programming languages are very particular about what you write and how you write them. Essentially, we're going to use characters and symbols and numbers. These things form expressions in R, and they need to be written in a very specific way that are defined by the rules, and those rules are the syntax. And unfortunately, one of the initial frustrations, particularly as a new R user, particularly as somebody who's new to coding, is that if you make even the smallest little deviation, you can get what's known as a syntax error. Okay, you'll go to write a code, you think everything looks good, you hit return, and then you get an error message that pops out. And this is really frustrating. And as a beginner, you're going to be making these syntax errors a lot. Okay, so just be prepared for it. It's just part of learning programming. And these syntax errors are going to be the things that you're going to see over and over again. And it's going to be really frustrating And also you might make some progress and then you're going to be typing more complex code. You're going to have more opportunities to make syntax errors, and you think you're making progress, and then you write some code and then you have this syntax error that pops up. You stare at your code for hours and hours and you can't figure out what's going on. And let me be there. I've been there myself. It's very frustrating, but please hang in there. It's just part of the learning process. And it's something that we all go through. And even, I consider myself an expert. I've been using R for a very long time. I still make syntax errors all the time. So it's not something that you're going to ever eliminate. But what does happen as you get more familiar with the language is that you're able to spot these syntax errors more quickly, and effectively allows you to fix them. So you might write a bunch of code there and you might make some problems, but with more experience, you can say, oh, yep, I forgot a comma there, or I should have had a closing parentheses here and there, and you're able to spot those for more quickly. So again, just be prepared. Part of the learning process, completely normal to make these mistakes. So, I think I've effectively covered all these main points here. One thing to note is, we'll see this in examples, but if you make a syntax error, R will generally let you know. In RStudio, you'll get a message that pops up in the console. It'll be in red. It will usually say error and have some message associated with that. Sometimes these messages are helpful and sometimes they're not. They can be very cryptic. So, but what is useful is if you want to Google for something, it's often useful to copy the error messages that you get, dump them into Google, and then that can maybe help you find some ways to get around the problem. Just as sort of a note, as you're typing R, obviously more complex expression than code gives you more opportunities to make these syntax errors. So try, I would say it's possible to break your ideas, your logic, your expressions into shorter expressions when possible. Sometimes it's nice, and maybe some experienced coders like to do some fancy coding where they're doing lots of complex things in their code. I always err on the side of readability and understandability. Even if I have to type more code, I'd rather have code that's more readable and understandable. And so, I would suggest doing that. It helps you avoid making these syntax errors as well. We are now finally going to get into some of our first R coding here. And the first thing we're going to talk about is variables and variable assignment. What are variables? This is an absolutely fundamental piece of any programming language, fundamental piece of R. And variables effectively allow you to store data using names. Okay, and so why would you want to do that? It makes your code more understandable. So let's say you're doing an analysis. You're going to be storing data, you're going to be storing computations, you're going to be storing results as you progress through analysis, and you use variables to keep track of these. Hopefully you use good, names for your variables so that you can understand what they are. So if you're tracking, for example, a set of proteins, you might make a variable called detected proteins or something along those lines. So you know that the thing that the data that you're holding, it represents proteins. So that's an example. Here is some syntax about making a variable and assigning a value to it. So the first thing is, on the left-hand side, you have the name of the variable, and then you have this strange assignment operator here. It is the less than symbol followed by a dash. And what's really important is that there is no space. Coming back to this question about spaces, this is a case where spaces matter. There is no space between the less than sign and the minus sign. Okay, these have to come together back to back. You can put, and I recommend putting spaces in front of this operator and behind the operator, but there can be no space between this. And effectively what this is doing is it's taking the value of 10, and the arrow kind of implies what's going on here. It's taking the value of 10 and it's assigning it to this variable, which I've called myvar. And as I mentioned, some of the benefits here, you want to use name. You can use names. We'll talk about what names are valid in R here in just a minute, but you want to use well-named variables. Rather than referring to explicit, what we say, hard-coded numbers like the number 10, it's better to refer to those by variables. If you use variables, it helps you reduce bugs. It makes your code easier to maintain. And so the takeaway here is that variables are a fundamental part of any programming or analysis you're going to do in R, and you're going to be using them a lot. We'll practice making variables here in just a minute. Naming variables is up to you. And this actually is often kind of a hard thing to do. You have to name things, and naming things often is a difficult thing to do. And by and large, you are free to name things however you would like, but there are some rules. We'll talk about those. Just a few considerations. If you have variable names that are too long, that can be cumbersome, because remember, we're going to be typing code out. So if your variable name has 100 characters in, that's probably going to be cumbersome to work with. You're probably not going to want to do that. That being said, if your variable name is too short, then it may not be informative, or the meaning may be unclear, and so that's not as useful. So another thing is if your variable is too general. I'm using my var just for an example here because I don't have a specific context, but that is probably a bad variable name in general, something I wouldn't recommend using for your analysis. You should use more descriptive variable names. It'll just help you in your code. Let's talk quickly about the naming rules of variables. Variables can only contain letters, numbers, underscores, or periods. Those are the only valid characters you can use in your variable names. This obviously is a big universe of characters, so it's not like you're limited that much, but you can only have these characters in your variables. There can be no spaces within the variable name. Everything has to be contained in one unit, if you will. Interestingly, your variable must either start with a letter or a period. So your variable can't start with a number, can't start with an underscore. It must start with either a letter or a period. I think it makes most sense probably to start with letters. And you can't, strangely, you cannot start with an underscore, a number, or a period followed up by a number. That's probably confusing. I have some examples here to make this a little more concrete. So all these variable names here are valid variable names here. Notice they only contain letters, numbers, underscore, or periods. Okay, these are all valid variable names. Notice this is a little weird here. We started with a period. That is valid to do in R. You don't often do that. It probably doesn't make sense in general to do that. If we talk about descriptive names, these are probably some good names for variables. This is a little bit of a long variable name. Maybe you would want to abbreviate minutes to min, but gradient min is a good example of a variable. It knows what kind of data we will be storing in that variable, or minimum MZ. That's another good one. These are some invalid variable names here. We won't go through those. Maybe if you wanted to practice a little bit, you could maybe after the course try to understand why these are invalid variable names. All right, practice time. We're going to start typing some real R code here. What I'd like you to do is, I say in the console here, but we also know, and frankly, I was kind of encouraging the use of the editor. So you can either do it in the editor or in the console. I want you to make a new variable called exp1 underscore time, and assign a value of 10 to it. Okay. Then I want you to, note some things here about what happened. Create a second variable. I want you to then add these two variables together and assign that to another new variable, and just kind of pay attention to what's going on here. So practice assigning variables is the key piece of these exercises. Again, if you need some tips here, if we go back to the slide, this is a key piece of the puzzle. Again, we created here a variable called myvar, and we assigned the value of 10 to it using this assignment operator, which was this less than minus sign. So I want you to practice this now using this expression here, and we'll cover these answers live like we've been doing. Let's give you about 3 or 4 minutes here to do that.
Ryan, could you also explain a bit in detail when to use the assignment operator or when to use the equal sign?
Great question. And this is one of the weird quirks about R. Most programming languages use the equal sign to make variable assignment. And in fact, you can do that in R as well. You can use the equal sign in R to do variable assignment. The reason why I didn't show that here is because by convention, variable assignment is typically done with that arrow-like looking thing, the less than minus sign. That is by convention. You can use equal signs if you like. And we will see the use of equal signs in another context when we talk about functions. But it's really just about conventions. You can use equal signs in R to do variable assignment, but that's not what the community does. If you look at other code online, that's typically not what's done. They use this other thing that looks like the arrow that I showed. So it's mainly by convention. And so I encourage you as a new R user to comply with those conventions and to use the assignment operator. Just has some weird R history. When R was actually the successor to R, which was a language called S, which was developed a long time ago. This was sort of in the early days of personal computers, and the keyboard that was, so I've been told and heard that the keyboard that people were using to write R actually had a single key on there that typed that arrow looking like an expression as a single key. So people didn't have to write didn't have to type two characters. They actually just pushed that one key to get that operator. There's also a keyboard shortcut in RStudio that will make that assignment operator for you with a keyboard shortcut. Great question. How do you add two variables together? Great question. So remember when we did the 1+1 example, we'll cover this slide. So I'll show you how to do this in a minute. Think about that and how we might apply the same thing, but using variables. Okay, so give that a shot. We'll cover the slide in just a minute. But great question. I'm using this term here, reassign this variable. I didn't really explicitly go over that. I will do that in a minute, but reassign, essentially assign a new value to this variable that we've already named here. That's called reassignment. Give it, I don't know, 15 more seconds here, and then we'll do this live together. All right, let's go for this. So I had said in this, you can do this in the console. We're kind of doing testing, kind of little throwaway kind of examples here. But actually, let me follow my own advice. Let's do this in the editor. So again, let's go to File, New R script. And we can work on that here in an R script. So the first question was about making a variable called exp1_time and assign the value of 10 to it. So all we need to do here is type exp1_time. I'm going to put a space. Again, this is an optional space. You don't need a space here, but I do like to use space. Again, it helps the code breathe. So I'm going to put a space there. Now I'm going to type the assignment operator less than minus sign. There is no space here. This would be a syntax error or an unexpected expression, actually. So no space there. These need to be back to back, and we want to assign a value of 10. Okay, so this is the expression. If you were to type this in the console and hit return, we would have essentially we would have made this assignment. I'm going to use, I'll use the run button here for this example. Let's again look at what happens down here in the console. Click the run button. We have now assigned this variable called exp1_time, the value of 10. And notice it popped this expression down in the console and executed it. If you may have noticed over here in this thing called the environment, we can actually see the variable name and its values here. So that's actually a nice kind of thing when you're doing analysis. This kind of gives you a record of what R knows about at any point in time. So that's a neat way to see that. Okay. So hopefully that made sense. So what happened after you pressed return? Let's do this in the, remember when we did our 1 + 1? We got an answer of 2 out. Let's take this expression. I'm going to copy it and paste it in the console and hit return. Nothing came out. Notice that 10 didn't pop out. You know, it didn't print out anything really. It just went return and gave us this new line for us to type an expression. Why did that happen? That happened because we just assigned this 10 to this variable. We did that assignment. We essentially made this variable known to the R system, and now it exists in our environment. But there's been no direct feedback necessarily of what happened, because things are happening behind the scenes, effectively in the memory of the computer. Now, I said, what if we were to take the name of the variable and press return? So let's do this we can do it in the editor or the console. Well, let's do it down here in the console, exp one time and hit return. Now we actually get the output of a variable. Okay, so if we just push the name, type the name and hit return, we can see what it contains. And so that's a nice thing. If you're working through scripts and you want to know what's the value of my variable right now, just type the name and hit return. Alternatively, you can also take a look over here in this environment tab here that gives you kind of like a real-time version of what's going on. So that's another way you can see the values of a variable. I said create a new variable called exp_time2 and make a value of 20. Let's do that up here, exp2 time. And then we're going to make a value of 20 for that. Okay, so let's execute that. Okay, so now we have 2 variables now in our workspace here. We have experiment 1 time and experiment 2 time. Again, if we type the variable here, hit return, we can see that expression. Okay, so we just made 2 variables. You know, fairly basic, but we are now holding data in R and we can do something with that. So I said, let's make a new variable called sum exp time. Okay, and that's going to be the sum of the values in the other 2 variables. How would we do that? Well, let's kind of follow the pieces that we know. We know how to assign a variable. So let's put the name there in the assignment operator. The main question now is, what do we put on the right-hand side of this operator? You know, before we had done 1 + 1. We're going to take the same exact idea here, but now instead of typing the explicit numbers, we can use these names of these variables now. Okay, which is really cool. So let's execute this expression. And now we have this new variable called sum exp time. We can type that variable and execute it, and it has the expected thing. We knew that exp time 1 was 10. We knew that exp 2 time was 20, so 10 + 20 should be 30. So we get what we expected here, but we did these all through variables here. We don't have any explicit numbers. And if you wanted to add 2 times together, actually this statement makes a lot more sense, right? We know that we're adding experiment times together. An equivalent expression is this, 10 + 20. But unless we have context, we don't know what that means. That just means we're adding 2 numbers together, whereas this actually has context. We're adding 2 experimental times together and saving those in a variable name. That's why variables are important. Okay, it gives context to your code. Finally, I had said, let's reassign exp one time to 30. Okay, so in this line of code, we first assigned it to 10. Let's now just do some copying and pasting here. And now let's assign this to, did I say 30? I think I said 30. Let's assign it to 30 and execute this expression. I mean, again, you can use command return or push the run key. Let's see what happened. Then my question to you is, well, what happened to sum experiment time? Remember that we had added these things together, but we just changed one of those variables. So let's see what this thing is here. Let's copy and paste this down here. And notice the sum of the exp time is still 30, okay? Even though we updated this variable, exp time 1, down here in this line of code, this sum has not been updated. And that's really important to know because we have executed these lines line by line, and we have not updated this variable. So if we updated a variable as part of this expression and we wanted the sum time to reflect that, we would have to go and re-execute this expression to reflect this updated value, okay? So that's what I did. I re-executed this after we updated this variable, and now sum experiment time now should equal 50, which is 20 + 30. And actually, you could have watched over here on the environment and seen how that updated and changed as well. All right. I bring that up because in Excel, if you've done Excel analysis, you oftentimes refer to pieces of data using the cell references, and those cell references update in real time. So if you were to update a number in a given cell that was used in another calculation, you could update that cell and everything that referred to that cell would also get updated. In R, we run things line by line, and how you run, the order in which you run these expressions will reflect the data that you have. Great, so let me stop here. Any questions about that, about variable assignment, about this notion of sort of running scripts line by line, about saving expressions? Any questions about that? Great. Okay. So this is very much a building up kind of, we're going to build upon things. So now in the materials that we use going forward and learn about, we're going to be using variable assignment quite a bit. So we're going to build upon that in our next section here. And we're going to talk about vectors. Okay. So this is a little bit under the hood here about R, but I think it's a really essential piece about learning about working with data in R. And then we bring up this concept of data structures. Okay, the data structures are a common theme, a common area of study in computer science in general. If you were to be a computer scientist major in college, you would probably take a whole course about data structures. What are data structures? You can essentially think of these as bags that hold data. Okay, and there's different bags for different contexts. Just like if you were to go to school, you might choose a backpack as a bag to hold your books and hold your, computer and so on. You would choose a backpack probably to do that. If you were to go on a vacation, probably a backpack wouldn't cut it. It might not be large enough, so you want to get a suitcase. So each of these bags has a different purpose for how they're used. And we have these same kind of concept of bags that hold data in programming in general and in R specifically that we'll talk about. These bags are effectively what I mean by data structures. If you know about programming languages, if you have any context, if you know Python, for example, Python also has data structures as well. I'd say all programming languages have these data structures, and they usually have similar kinds of bags, but they can be named in different ways. And confusingly, for example, a vector in R or an array or a list in Python might have a different meaning in another language. So just note that there is not a consensus on how to name these things, and that the same name for a data structure might be used in different ways in different languages. So just note that, but we'll talk about the essential data structures in R. Those two things are vectors that we're going to talk about here in this section. And then at the end, we're going to talk about data tables or data frames that store tabular data. There's another type of data structure called lists. We're not going to cover those here, but those do exist just for reference. So what's important here about vectors? Vectors hold sets of data of the same type. What do I mean by type? I mean by the kind of data that it is. So for example, a number is a kind of data type. A word is another kind of data type. And so with vectors, you're going to hold data together that are all of the same type. Let me give you an example that you're probably familiar with working with mass spectrometry data. In mass spec data, we often look at M/Z values in a mass spectra as well as intensities. And there is an order to these things, and there is a relationship between these things. So one way in which we could represent a mass spectra is to use two vectors. So one vector that stores M/Z values, another vector that stores intensity values. And what would be important here is that these vectors should have the same number of values in them. We say they have the same length and they're ordered the same way so that we have M/Z and intensity pairs. Okay, so this is one way in which we might want to represent mass spectrometry data as two vectors. So any questions about that? Sort of like the fundamental motivation of why we want to use vectors. We want to use vectors anytime we want to collect data together into a single entity. Okay, let's talk about how we create vectors in R. we're going to use a function. We haven't talked about functions explicitly. We'll talk about those in a little bit, but we're going to use a function that's a part of the base R language that will allow us to make a vector here. And that function has a name, and in this case, it's the unfortunately named very short name of C. This is a function that is going to combine a bunch of individual elements into a vector. So in this example, we have this myVec variable. We already know about this. This is the name of the variable. This is the assignment operator. We're adding on a new piece here where we're going to construct a vector. We're going to use the C function. We're going to use these parentheses, and then we're going to put a list, a sequence of numbers here. Okay, these things are all going to get wrapped up into a single thing known as a vector, and we're going to assign that to a variable called myVec. Okay, so really kind of simple here. But there's a lot of syntax here going on in terms of the name of the function, these parentheses and so on, the commas, but this is, you'll get more used to this as you work with vectors. We can a really cool thing is we can perform math with vectors. So just like we added 1 plus 1 to get a single number out, value of 2, we can add vectors together. And this is really useful way to do computations. You probably do this already in Excel, where you select maybe 2 columns of data and you make a formula, and then you drag that formula down using the little handle on the right side of the box. If you've done that in Excel, this is completely analogous to essentially performing math with vectors in R. So it's the same idea and the same concept. There are 2 main patterns, and we're going to practice this in just a second. For working with vectors in R, we're going to either have a vector of values and then a single value and perform math on those. And what's going to happen is that single value is either going to be added or subtracted or so on to every value in that vector. Okay, so we're going to take one value and apply the math operation to every individual entity in that vector. The other use case, and this is really useful, is if you have 2 vectors that are exactly the same length, you can add those together. And what it's going to do is element by element operations of math on those 2 things. So we'll add the first 2 things together, we'll add the second 2 things together, and so on. And then the thing you get back out is going to be a new vector where we've essentially done this math. We've done this operation here. It's going to be the same length as the inputs. And you'll have that output that, again, you can assign to a variable. Just as a word of caution, and be careful, you can add or operate on 2 vectors that are not the same length, but absolutely do not do that. It's possible, but it will get you into trouble. And just a note here, and we'll practice that in just a minute. But either when you're going to operate on vectors, you either take a vector with a single value or 2 vectors of the same length. Let's make that concrete with some examples here. Here is some code, and you can go and practice these after the course as well. I think it would be great for you to execute these codes and look at the outputs to do this yourself. This is an expression here. We already know about variable names and assignment. We're going to make a vector here that has these 5 values in it. Okay, so we're going to make this variable. Then we can write this code, myVec plus 1. This is the output here, and I think you could probably guess what just happened. It added 1 to every entry here in the vector. So the output became 31, 41, and so on. We can do multiplication. So maybe we want to multiply everything by 2, and we can do that, no problem. As I mentioned, so these are examples of using a vector with a single number on the other side. This is an example of adding 2 vectors together. So there's no reason you can't add the same vector to itself. So in this case, what did it do? It element by element wise added the first entry together to get 60, then 40 plus 40 to get 80, and so on. So it took the vector element by element and added things together. Perhaps unsurprisingly, if you subtract a vector from itself, you're going to get all zeros. And this is an example where we use variables, but you could also explicitly define a vector here to do the same kind of thing. Okay, so any questions here about vectors and doing math on vectors? This might seem a little low level, but this is really important, sort of a fundamental piece of working with data in R. You implicitly do these kinds of things, for example, when you do data analysis in Excel. And this is how you accomplish those things in R. So we're back to practice time here. We are going to do some math with vectors. What I'd like you to do is, again, either in the console or the editor, because we know how to execute code in either place. I want you to create a vector with the values 1 through 5. Hint, if you go back to the previous slides, you can find some code that does that. It's up to you to pick the name of what you'd like to do. And I'd like you to go back and rerun these things in the code just to make sure you can do it. Maybe try to retype them yourself. That's a good example of trying to get more familiar with the language. So run these in the code, and I just want you to get experience running these things and what things look like. Okay. And then the very last thing, I'm asking you to try to do what I told you not to do. Take a vector, we know it has 5 values into it, and add a new vector that only has 4 values. Again, don't do this in practice, but I want you to see what happens when you execute this expression. You'll actually find that an error does not come out. You can do this. This is a valid expression in R, but it kind of does a weird result that can be difficult to work with. So let's take a few minutes here and go through these examples.
Hi, Ryan. There was also a comment of like going through the environment window while like doing the exercises to see what's happening there.
Yeah, it's a great, yeah, was that sort of just a tip to use that to take a look at?
Yeah, they were like getting confused and wanted to know what else they can do like with the variables there.
Got it. Okay, let me go there. So this
Ryan, before you go there, there's a
please.
other relevant question that you can
Please.
cover both of them, the environment
great.
section.
Perfect.
So it's
Great.
about the how we can save the variables so that every time that we open R, we can use them. Since the variables are saved in the environment, maybe we can talk about that here as well.
Okay. Yes. Okay. Let me cover the first thing about the environment, and then I have lots of thoughts about that second question, and there are some differing opinions here, but I'll cover that in just a second. The environment here, think of this just as a view into the variables that R knows about. Okay, so we're not really going to modify, for example, these values in this window here. This just gives a view. It's like a window into what R in the memory knows about. So just use this as a way of sort of looking at and visually keeping track of the variables. You're not going to edit anything from here. You're going to do that in your code over here. Okay, so this is really just a helpful thing to look at. The other question, how do we save variables so that when we load R up, we can access them again? There are differing opinions about this. I have a very strong opinion about this, and I would say you never want to do that. Okay, there is ability to do that. There's ability to save variables as part of an R data object. And in fact, if you quit R, sometimes it will ask you if you want to save sort of your history and your environment. I strongly recommend that you don't do that. The reason for that is that can become a reproducible nightmare. Anything you want to save about variables should go as an expression in your R script, okay? So if you're doing an analysis, you shouldn't rely on the fact that you saved something yesterday to a variable. You should have an explicit line of code in your script that created that variable and assigned a specific value to it. So I realize that R gives you the ability to save variables as part of sort of your environment in an R data object. I highly, highly recommend that you do not do that. Encapsulate everything that you do in a line of code in your script. That's how I strongly recommend that you work. Right. So in the interest of time here, let's just go through these things real quick. Okay, so let's do the following. The first thing was we need to create a variable name. Let's call this, oh gosh, myvar. Sorry, I'm not very creative. Myvar, and it says to assign the values 1 through 5 there. We're going to use some new things that we learned. We're going to use this C function here. C function here with the parentheses, and we're going to put the numbers 1 through 5 here. Notice I put spaces here again. You don't have to. This is another case where you can have optional spaces. I like spaces again. Like I said, it makes the code breathe and makes it easier to read, in my opinion. Okay, so we have the myvar here. It shows up now into our environment, and we can see now it's not just a single number, but it tells us that these are numbers here. It has indexes. These are sort of the range of the values of 1 to 5 here. And we can do things with this. Let me go down and maybe, well, I'll do it up here in the editor. My var +1, as we saw, adds the values 1 to each thing. So instead of 1, 2, 3, 4, 5, we now have down here 2, 3, 4, 5, 6. We can, add my var plus my var to add it to itself. No surprise that we just doubled things. Let me try that last example where, again, I told you don't do this. This is bad, but we can do my var and we can add that to another expression here, another vector here that has only 4 elements to it. Okay, so let's run this code here. Okay, so it executed, as we can see down here. Notice it did give us a warning message, so that's nice. This is not an error. Okay, so a warning message is different. A warning message says, is a message from R that says, hey, I just ran what you did, but by the way, you may have done something unexpected, so I'm going to let you know about that. That's what this warning message is, and it tells us longer object length is not a multiple of shorter object length. Kind of cryptic, but I think you can parse that. Essentially, it's saying that this vector here is shorter. It has fewer elements than this vector here, which has 5. This thing has 4 and this has 5. That being said, it did actually return a value to us. Let's try to figure out what happened. It added 1 to 1, so we got 2 out of here. It added 2 to 2, so we got 4. It added 3 to 3, so we got 6. It added 4 to 4, so we got 8. But then we ran out of values here. We don't have a 5th number to add to this 5th thing. So what did it do? It went back to the very beginning and added 1 to 5, okay, to give us 6. Okay, so that's weird. It like wrapped back on itself. You could probably see that this can be a dangerous thing to do. And something that you probably shouldn't do unless you have a very specific and advanced need and understand what you're doing. Okay, so that's that example. Look for these warning messages. They can be helpful when you're doing things that might be dangerous. Okay, any questions there? Okay, we're going to talk about functions here. And just so you know, this is kind of sort of the main section where we're learning about syntax. So we have a lot of meat here to be going through. So functions here. We already learned about a function before. That was the C function that allowed us to combine, that's where the C comes from, combine different elements to make a vector. That's just one function that the R language gives us by default. And there are a ton of other functions that allow us to do interesting things in R that allow us to operate on data. And so importantly, functions have a name and optional inputs to the functions. Okay, these inputs, like we saw with the C function, was just a set of numbers. Those are inputs. They go by a strange name also called arguments. It's just one of these weird names that computer scientists have decided to call the inputs. These are sometimes called arguments. The things that you give to the function for it to do things. The name comes first. So how you use these functions is you type the name, and you have to type the name exactly right. You can't make a typo. You can't, make an. You have to type it exactly as it is, and then you add a open parentheses. You add your inputs, and then you add your close parentheses here. I put this ... here just to say that there might be more inputs available. So that's not something you necessarily explicitly put in when you use the function. That's just to indicate that there could be lots more inputs here. What's cool is that R itself has a bunch of functions. I mentioned some like computing the mean and median and doing linear regression. All these functions exist in R. You can download additional packages like the packages that Olga and her team develop to get additional functionality for dealing with mass spec data. And you can write your own functions. We're not going to cover that here, but just want to let you know that all this function opportunity is available to you and is really powerful. So let's take a look at some of these functions that are useful for doing data analysis. And all these functions, excuse me, all these functions are available to you as part of the base R environment. So given a vector, things that we just learned about, we can use these functions to operate on the vector. So if we want to know how long the vector is, we can use this length function. If we want to find the minimum element in there, say a minimum number in a set of numbers, we can use the min function. The max does the maximum. If we want to sort things, we use the sort function. Notice that these function names hopefully have descriptive names so you know what they do when you use them. If you just want to get the unique elements, you can use this unique function. And we also have the mean and standard deviation. Pop quiz, if you wanted to calculate the median on a set of values, which function do you think you might use? Perhaps unsurprisingly, there's a function called median that you can use to do that. The key piece to this puzzle is just understanding what these functions are named and what they are and where they exist. That's where Google searches, that's where experience, that's where looking through other code can help you inform you what kinds of functions are available to you, but there are a ton of functions in R for you to work with your data. Sometimes I even learn new functions that had been around from the very beginning of R and I didn't know about them and I learned about them because they're really useful. And then I incorporate those into my data analysis workflows. So let's get some examples here of working with vectors using functions. So just another example of making a vector here through variable assignment. We've already covered this. We already know how to do this. We can use this length function on the vector to get how long it is. So this thing has 6 values here, and this is a way in which you can do that. We can get the minimum value, which in this case is 10. We can get the mean of that, which happens to be 22 or 28.3 repeating. Notice that this vector is not in numerical order, so we can use the sort function if we wanted that to be the case. Notice that I have duplicated the number 20 here twice, and there's no problem. You can duplicate values in a vector, nothing wrong with that, but sometimes you might want to get the unique element, so you can use this unique function to do that. All right, so some practice time here. I think in interest of time, I will just go through this live here so we can keep going here. But again, you can go back after the workshop here, and I would suggest going through these yourself so you can get access to this. So let's take a look in RStudio and do some of these examples. So I said here, let's create a new vector with the values 1 through 5. We did that before. Let me get rid of this code. All right, so we have this variable, the values 1 through 5 here. How can we confirm that this vector has 5 elements? Well, one way is to simply count the number. The data is small enough here, so it's easy to count this. In reality, you're going to have data that's much, much bigger than that, and you're going to not want to have to count that by hand. Hence, we can use this length function, which I introduced. This is the name of the function. We type the open parentheses and type the name of our variable here and execute this. And we can see that the length is 5. It confirms that we have, in fact, 5 elements. I showed some other examples there. Like, let's take a look at the sort of my var. Sorry. Again, this will sort the vector for us. It was already sorted. Let's just add another element here, 10, as an example. It's not sorted, but when we run the sorted case, it puts 10 at the end. It sorts it. Okay, there are a ton of stuff. We can also do the median. I talked about median here of my var. That will give us the median of this thing, which is 3.5. Okay, there's lots of functions here. Again, like I said, Google is a great place to go and try to find these functions, looking at other people's code, reading documentation. Let me point out a very important piece about learning about a function. Imagine you wanted to know what a function does. In R, you can do that by typing the question mark and then the name of the function. Let's put the main function in here. We don't put any parentheses like this. We just type the name of the function and hit return. And then notice in RStudio, it pops over to this help browser here that gives us information about what this main function does. Let me admit, as a beginner, some of this function might be a little bit difficult to understand exactly what they mean with everything going on here, but hopefully it'll be a little bit helpful. It tells you that it computes the arithmetic mean, and it tells us how to use this function So we put an X here, and this is an R object. It typically is a vector of values. So we know that we can supply vectors here. There are some other arguments here if we wanted to apparently trim the data in some way. Some other details here about the data, but that's really important. If you want to learn about a function, just type the question mark in the name and hit return, and you will get a help browser. If you want to get back to the files things here, you just click on the files tab to get back to what we saw before. Okay, so that's what we just walked through some of these use cases here about this idea of calling functions. Calling is a weird term. Again, another one of these computer science terms. Calling function means just using the function. Using the function in your code is said to be said that you are calling the function, is what that means. Let me show you something here that I'm trying to show you in for here. Let's say that you wrote a function like the median. And notice RStudio here is kind of trying to give us tips about what it knows about function names. It knows about this function name and provides some tips here. If you were to hit the tab, remember we talked about the tab to complete the name of the file. If you hit tab right now, it would complete the name of that function and add parentheses for us. So that's a little nice convenient thing. Imagine we wanted to compute the median of my var, and we forgot to add the closing parenthesis here, and we hit return. You'll see that we have this little plus sign hanging out here. R is waiting for us. It's saying, hey, Ryan, I'm waiting for you to do something. You didn't have a closing parentheses, and I want you to give that to me. And you might, let's say you have a complex expression, you don't know what's going on, and you see this plus sign. You're like, okay, I'm going to hit return, and you are stuck. You can't get anywhere. It won't let you do anything. There are two ways to get out of this. One is to fix the mistake, so you can actually put the closing parentheses and it will execute. The other option is, if you see this, just press escape. It'll essentially allow you to exit out. So if you ever see this plus sign on the left side and you can't do anything, just press escape. It will get you out of this weird little situation where there's something incomplete about your expression. All right. Okay, so any questions about using these functions? There's a whole bunch. They're really useful for doing data analysis. You can probably already think about some ways in which you might use some of these functions in your own data to understand what you have. Okay, let's keep going here. We're almost through this section. We're going to talk about sort of one last little piece in this section about conditional expressions. Again, we're not covering all of our syntax, but we're covering the fundamental pieces that are really important for doing real data and analysis. And one of those pieces is conditional expressions. And just really briefly, conditional expressions allow you to ask essentially yes/no questions about your data. And you do this all the time. You do this in Excel, you do this maybe in other programs. You might do this mentally when you're thinking about and working with data, effectively asking yes and no questions about the data. So for example, where would you use this? Maybe you have a list of detected peptides from your proteomics experiment, and you want to just get the peptides that have a false discovery rate of less than 1%. This is an example where you could, in R, you would use a conditional expression in order to get peptides with a false discovery rate of less than 1%. This is exactly the case where you would use that. This happens all the time. I use conditional expressions all the time in my day-to-day analytics activities, and it's really important. As you probably can guess, those kinds of questions are like that. Give me values that are equal to a certain value or bigger or less than a certain value. And so as a result, conditional expressions use these logical operators to effectively test or ask these questions. So we're going to use things, these are common things in math that you already know about, obviously. So fortunately, that's the same. We have like a less than operator, we have a greater than operator. You can also ask less than or equal to, and that's, you use two symbols here, the less than sign and the equals. Again, you can't have a space here, just like our assignment operator, you can't have a space between these things, you have to put them together. We have greater than or equal to. So these are, pretty straightforward operators. A lot of times we want to ask the question, are two things equal to each other? Is the peptide we're interested in equal to this particular peptide sequence? You do that using the equals to operator, which is two equal signs back to back. There was a question earlier that asked about assignment operator that uses the single equal sign. Okay, the single equal sign can be used in R for assignment. I suggested that you don't use that. I suggested you use that arrow operator, but the equal sign does variable assignment. The equal sign does not ask if two values are equal to one another. So that's really important to note. To ask if two values are equal to one another, you have to use a double equal sign. And I sometimes forget to do this all the time. I meant to type the double equal sign. I only put an equal sign there, and things don't work as expected. So it's just a really important thing to note. We also have the not equal sign here. In R, you put the exclamation point followed by the equal sign. So maybe you want to say, give me all the peptides that are not equal to this particular sequence. You would use this operator to do that. Conditional expressions. This is a question. Remember, we're asking a question, a yes, no question. So you would expect the response from the computer should be yes or no. Is my data equal to this? Yes or no. R does that by giving you back what's known as a logical value, true or false. So true is yes, obviously false is no. So effectively a conditional expression answers back with yes or no. And as I mentioned, these are known as logical data types. This is a type of data in R. It's different than a number. It's different than a word. It is a thing that deals with yes and no questions. Please note that these things are all caps. So you write true with all capital letters, false with all capital letters. You do not write lowercase. You do not capitalize the first letter. You do not mix the cases. You write true and false all in capital letters, just the way that R works. Here are some examples of working with conditional expressions. Imagine we have a value here, it's 123, and we have a vector which has these values here. We can ask the question, is my value greater than 100? Well, we know it is because it's 123, and so R is going to respond true to that. Is my value equal to 122? Again, we use the double equal sign to ask the question of equality, not the single equal sign. R will tell us that the answer is false because 122 is not equal to 123. Look at this one. This is interesting. But hopefully it makes sense here. We can also ask this on a vector. Is my vector greater than 20? That's kind of a weird thing to think about. Remember, a vector has multiple values, but what R does is asks this question over and over again for each element in our vector. So this expression says, is 30 greater than 20? Yep, it is. Is 20 greater than 40? I think, I'm sorry, I got off here. Is 20 greater than 40? I think I have a typo here, and this is great. So we'll execute this in the console to go through this. This will be a good example. You also can assign this output of a vector to a variable. So that's oftentimes what you want to do. Let's go and execute this code in R, and we can see what it actually is. So let's get these two expressions here. We have my value and my vector. So let's execute these. So our variables, so our environment knows about this. So again, let's ask that question. Is my vector that greater than 20? Is that what I said? Yes. Okay, that makes sense now. So let's do this. So my vector, is it greater than 20? And it gives back the answer, true, true, false, true, false. Is 20 bigger than 30? Yep. Sorry, is 30 bigger than 20? I was saying that backwards. I was getting my brain was flipping. Is 30 bigger than 20? Yes. So that's why we get a true. Is 40 bigger than 20? Yes, that's why we get a true. Is 10 greater than 20? Nope. So we get a false, and so on. So I think you can kind of see how we can ask multiple questions here about our data here. And this is really useful and allows us to do an important thing about filtering data that we're going to talk about next. So any questions about that? Okay, let's go back to here. Okay. So we talked about some practice time. Again, we kind of worked through these. So I'll leave these as something you can do after the workshop. As the final piece, we're going to combine all of these things that we did together to talk about subsetting vectors. Okay, and this is useful when you want to get specific values from a vector. Okay, for example, we want to get all peptides that have a false discovery rate less than 10%. We're going to use a new operator known as the square brackets. We'll see some code here in just a second. And there's a few ways you can do that. You can get subsets of data based upon their position in the vector. So like if you want to get the first element, you can put a number 1 in these brackets to get the first element. You can also use these logical vectors so that those conditional vectors that I just talked about, we can use those with the subset operator here to get different values here based upon whether or not a condition is true or false. Just as a side note, if you know about other programming languages, strangely, most other programming languages start counting at number 0. So the first element would get the number of 0. R starts with the number 1, which seems to make sense. So if you want the first element of a vector using an integer position, you use the number 1 to do that. Let's take a look at some examples here. Lots of repeats here. We know how to make a vector and assign it to a variable. If we want to just get the first value of a vector, we use these square brackets and the number 1 here, and that gives us the first element of 30. If we want to get the 5th element here, we just put the 5 in there, and then that will give us 20. We can also take a vector, use the square brackets, and put another vector inside of that. And this tells us to get the first, third, and 5th element so that we get 30, 10, and 20 out. Let's take a look at this really powerful piece of code here. So remember, we could ask a question about the vector that says, is my vector greater than 20? And we asked this question for every element in our vector and got out true, true, false, true, false. We can supply this condition here inside of the square brackets. And this is a little bit of complex code syntax, so you might want to stare at this for a little bit. But the idea is that we can take my vector and we can subset it using the square brackets for only cases that are greater than 20. And you can see that the output is, in fact, all of the values in this vector that are greater than 20. So we've excluded 10 and 20 from that. 20 is not equal, or isn't greater than 20, it's equal to 20. So this is a way in which we can subset vectors, and this happens all the time in data analysis. So really a fundamental piece of things for doing data analytics. Any questions about that? I admit there's some complex syntax here, but I think if you break it down into pieces that we have covered previously, that will start to make sense, particularly if you work these examples in RStudio. Okay, so we have some practice time here. Essentially, it covers those things that we looked at. Let me save that again so we can get into the final pieces here. We have about 45 minutes left, and I want to make sure I leave some time for questions. So we have some examples that I'm going to give to you at the end to practice as well. That'll give you some opportunity to practice for that stuff, and then we can answer questions and cover questions again starting tomorrow. Okay, so this was really the big core section about getting some fundamental pieces of the R syntax, the R language. It may seem like maybe some disjointed pieces, but they all actually did build upon one another. And it may seem fairly basic, but we've actually covered some pretty important pieces where if you were to sort of take the main ideas and concepts here, you could actually start doing some data analysis with your own data, that you have to work on yourself. So let's now, this is a very short section here. I just want to quickly cover about reading data files into R. We already did this a little bit at the beginning. I just want to recover it now. So the goals of this module is about how we can get data into R. Obviously, if you want to work with data, R needs to know about it and you have to read it into R. So that's the first step. Again, we're going to talk about RStudio projects and why we are using those that help with file paths. And we're really going to focus on CSV files, formatted text files. R can read other files. It can read mass spec files. It can read Excel spreadsheets. We're not going to cover that here because that's a little more detailed, but just note that R can do that. So as I mentioned, if you want to work with data, you need to get it into R. R can read all kinds of data formats. The easiest is formatted text files like CSV files, comma separated value files, or TSV files, tab separated value files. Those are the ones we're going to focus on. But it also can read a bunch of open standards. So it can read web formats, JSON files, if you've done any web development, markup formats, R can read all these kinds of things. It can read some binary format files that maybe aren't open. It can read MS data files. So for example, MZML is a common open standard for mass spec data. R has packages to read those. So this is all a possibility to do in R. There are typically reader functions that allow you to read this data. And as I mentioned, we're going to focus only on formatted text files because these are the easiest to work with. And frankly, are ubiquitous. Lots of programs can export data as CSV files and you can read those into R. We just briefly use this read.csv function to read comma separated value files. There are other versions of that. There's a read to lim if you have tab separated files and so on. Going forward, we're going to use a library called the readr package. It's part of the tidyverse that we're going to talk about more tomorrow, but we're going to use these functions very similarly named, but they just have an underscore instead of a dot. These are more modern, more recent reader file functions that allow us to read files. Particularly, we're going to focus on this read CSV file. So it's really actually pretty simple here. To read a CSV file using this readr library, we need to do two things. First, we need to load this tidyverse package. In the GitHub repository in the pre-course setup, I walked you through the ability to load this tidyverse package, and you can do that through RStudio very easily. So hopefully you've done that. If not, you can take a look at the GitHub page about how to do that or ask the TAs. But we load this package effectively this way that will give us the access to this read function. And essentially what we do is we just call this function read_CSV. We put the name of the file, make sure this file is inside of your RStudio project directory. Like we talked about at the beginning, we talked about how to do that. Make sure that file is in that directory. Make sure you're using an RStudio project. And if you're doing that, you can just read the data just by typing the name of the file here. You'll probably want to save it to a variable. So you would assign it there just like we did before. Bit on the directory structure. Recall that the RStudio project is really just a directory. It has this RStudio project file that hangs out. You may want to organize your data a little bit more if you have a lot of data files. So maybe you want to make a folder called data and put your data inside of there. You're certainly able to do that. If you do that, you just have to now give a relative file path to where this file lives. So in this case, you would need to type the data folder name / and then the name of the file. Okay, so it essentially says, starting from this project directory, where does this file exist? Well, it exists in the data folder by this name. So you have to modify this data structure a little bit. A couple things about CSVs, not too important here. You can maybe cover this if you want, but there are some things about CSV. Sometimes CSV files are well formatted and sometimes they're not. If you make CSV files, I have some tips here about what I suggest about making sure they're well formatted. Sometimes you get other CSV files that aren't well formatted and you may have to do some, you may have to fix them up before you can read them. So there are some notes there that you might want to take a look at. As I mentioned, you almost always want to save the output to a variable. So variable assignment, this pattern of assigning your data to a variable almost always happens. If you're reading a CSV file, the thing that you're going to get back out is a data structure known as a data frame, which we're going to cover in just a minute here. But effectively, you're going to get a data table out because the CSV file itself represents a piece of tabular data. There was a question about how much RAM do I want on my computer and what R is sort of capable of working with. Generally speaking, if you have a computer, a modern computer, laptop that has something like 16 gigabytes of RAM, you can usually work with most data files in R that are, say, hundreds of megabytes, maybe up to a gigabyte or two. R should be able to read those in without issue. If you get above, gigabytes, many gigabytes into tens of gigabytes and above, R is probably going to have a very hard time doing that. In which case, a couple of things you could do is you could get a computer with more RAM. I realize that may not always be an option, but that's one way you can do it. Otherwise, you might need to go to more complex ways of working with these data files. And we're not going to cover that here, but just kind of note that sort of hundreds to a gigabyte in file size, usually R can work with fairly well. When you go beyond that, you might start having some issues.
Ryan, in terms of reading the data, like here we are reading a CSV file. There was a question of reading a .raw file. How can we read those types of files in R?
Great question. So I think we're talking about maybe like a .raw file from a mass spec vendor format.
Yeah, correct.
That is more complex to do, mostly because those file formats tend to be proprietary in nature. That being said, I haven't done this in a while because I usually convert mass spec data to open formats like MZML. And there are other functions that can read those MZML files. I believe there is I think a .raw reader in R. I should actually make a note to investigate this as well. The short answer is it may be possible. One way to do it is convert to an MZML and then use another package. There's a MZR package in Bioconductor that can read MZML files. It is definitely more complex. Happy to talk about that in questions at the end, but does go beyond the scope of what we're covering here. But what you could read from your mass spec data, for example, is an output peptide or protein group table, which can usually easily exported as a CSV file. That's a perfect example of some data that you can work with here with CSVs. All right, so we don't have any examples here. I mean, we worked with this before. Just note some of those examples. I mean, really, this is kind of the key slide, how to read the data. You just need to get it into the project folder and use a read function and assign it to a variable. Okay, so any questions about that? Okay, this is the last section of our course. People doing okay? Thank you for sticking here. I know we're going through a lot of information, and this is sort of an intensive session. So let's go through this last section here, talking about a really important concept of working with data frames, because most of the data we work with is tabular in structure. If you work with data in Excel, it's effectively a table. I mean, that's what Excel is. It is a table. And so working with data tables is fundamentally what you're going to probably be working with on a day-to-day basis. Hence, it's a really important thing for us to learn about and know how to work with. So we're going to understand what a data frame is. We're going to learn how to take a look at data frames, review them and be able to work with them and be able to perform some basic operations on them, including getting subsets. Again, that's a really important fundamental thing to be able to filter and work with data frames. And just as a preview for tomorrow, we're going to even go a little bit deeper on data frames and talking about how we can do some really interesting and powerful data analysis pipelines using the package of dplyr, but we'll get into that tomorrow. So why is tabular data important? Why are data tables important? It's because they're ubiquitous, they're everywhere. As I mentioned, Excel by its design is arranged in a table. It's a table format and is a great place to work with data. CSV files fundamentally represent tabular data. We use tables to communicate data all the time. So this is an example table from a journal article. I mean, we see tables all the time. They're everywhere. So tabular data exists all over the place, and it's a fundamental way in which we work with and interact with data. No surprise, I think this goes without saying, but tables have a structure, and it's really important to think about the details of this. Tables effectively arrange data in rows and columns that represent cells. A little bit of a no-brainer, but just want to reiterate that this structure is really important for how we think about and represent data. So for example, typically data in a given row has a relationship to each other. We can see here, this looks like we're looking at some peptide sequences here. We know that because this peptide sequence is in the same row as this precursor charge state, that we know that this charge of 3 refers to this particular peptide, right? So a table gives us a relationship for how data relates to each other and allows us to effectively work with data in a systematic way. That's why tables are so important. R stores tabular data in a data structure known as a data frame. Okay, so that's that term is used sometimes in other contexts, in other programming languages, but it's really not necessarily true in all programming languages. R uses the term data frame. And I would argue that lots of data, if not most data you encounter in the real world, can probably be represented as a table, okay? And even if it can't, you likely probably want to get your data into a tabular structure because it just makes it easier to work with. So data tables are really a fundamental way of working with data. Most of the read functions that I just talked about themselves, when they read the data, they give you back a data frame structure. So they don't give you back a vector per se, they give you back a data table known as a data frame. It's a slightly different object. This is just a side note, and it's a little bit just some naming conventions here. We're going to be talking about the tidyverse tomorrow and why it's so important for doing modern data analysis in the R ecosystem. Just for naming conventions, the tidyverse uses a data frame, a tabular data structure known as the Tibble. It's a silly name, I know. I think it's sort of a play on the name table, but it's Tibble and who knows. But when you hear the word Tibble, just associate that with a data frame, a tabular piece of data. Okay, so effectively, when I say the term data frame, I really refer to that generally. That could either be an official, what's known as a data.frame object in R, or it could be a Tibble object that we're going to be working with, or more generally, you can think about it as a table, a rectangular table of data. If we look at a Tibble and you print one out, and we'll give an example of this, it actually gives us a lot of really cool information, summary information about the table just by printing it out. So we're going to work with an example here in just a minute where we're going to read some data here. If we print that out, that table to the console, this is an example of the output we get. R tells us that this thing is a Tibble. Okay, it's essentially a rectangular structure, and it tells us how many rows and columns it has. So immediately we can tell how big our data is without really doing anything else. It shows the first, this is by default. When you look at a Tibble object, it shows the first rows of data by default. So you don't, let's imagine you have a table with 1,000,000 rows. If you printed that out to your console, you don't want to see 1,000,000 rows of data flood out into your program. That is not very useful. And so by default, it shows the first 10 rows of data. To give an example, you can certainly access all the other rows if you'd like. It gives the name of the column names here. And if it's too long, it will truncate it, just again to save space, but the full name is there. This tells you about what kind of data is there. So this CHR means these are words, these are character kinds of data. So we can store those in R, but these are numbers here. This is an unfortunate name in programming. Sometimes numbers are referred to as doubles. That has to do with the numeric precision of the data. And it was kind of a funny name, but doubles refer to numeric data and so on. It also didn't print out all of the columns of the data. So it tells us that we have 9 more variables that it didn't print out. And these are their names and those are the data types. So this is really cool. We get a lot of information about the table just by printing it out. That's what a Tibble gives us. All right. We can work, just like we had functions for working with vectors, there are functions that we can use to work with data frames to understand more about them. So if we wanted to get the number of rows and columns, we can use these functions called nRow and nColumn. If we wanted to get both of these things together in one go, we can use a function called dim that stands for dimensions. Remember, you can put a question mark in the R console followed by the name of the function and hit return, and you'll get the help function, help documentation about that. If we want to get all the names of the columns here, so these things in our table, you can use the names function. I'll show this really cool thing called view, which will give us effectively an interactive table that we can use to look at our data. And then this is a little weird, but if we want to get the data from a particular column in our data frame, we can use this $ operator. So let's say we wanted to get all of the precursor charge states in this table. We could use the name of the table, then put a $ here, and then the name of the column here. So a little bit of weird syntax, but just what R uses. Okay, so let's do some practice time. And again, in the interest of time, because I want to be able to save some questions at the end, I'm just going to work through this live with you. And again, I encourage you to go back and do these things on your own. Okay, so let's do this. Let's go back to R. Let's do the following. I want to make a new project just to hammer home the idea that making RStudio projects is useful. I'm going to make a new directory, a new project. I'm going to call this test2. These are bad names. I already have a test project here, so let's call this test2 and let's create the project. The instructions here says that I want you to get this data file here, this example data file. So we're going to go to our exercise data that we downloaded before. We're going to get this annotations file here, and we're going to copy this into our new project directory here. Let me do that. So in this case, I just drag and drop the file. You could copy it in other ways, but now we can see in our test2 R project directory that this file exists right here. We can see in the file browser that it also exists over here. Great, so we're doing good. Let's make a new R script for us. And this code tells us what to do. So we're going to load the tidyverse package. Let me just reiterate, if you have not installed this package's instructions about how to do that are in the GitHub repository. It's a straightforward way to do it in R, but I won't cover that right now. So we need to load this library. Let's execute this line of code. Let's see what happens here. There's going to be some output here. It's going and loading a bunch of packages here. You can safely ignore this output effectively. Unfortunately, there's kind of this menacing word here, conflicts, that seems bad. In certain contexts, it may be an issue, but for all intents and purposes and what we're doing here, you can just ignore these outputs. This just tells us that it loaded this tidyverse package. Now we're going to read this data here. Actually, let me type it out live and show you some useful functions of R. So we're going to type dat as the name of our data, or let's call it my dat. That's fine, whatever. We're going to use the assignment operator, and then we're going to recall. We're going to use the read CSV function. I'm going to put the double quote character, and I'm going to type CH, capital C, lowercase h, because that's what the file name looks like. I'm going to press tab, and it's going to complete it for me. You could type that all out. Good luck. If it were me, I'd probably make a typo somewhere, but you can use the tab complete. And let's execute this line of code. Okay, so now it gave us some information here. Again, you can probably safely ignore this here, just giving some information about what it did when it read the data file. But now let's type this, this variable that now holds the contents of this CSV file in this variable. Let's type it at the console and hit return. And as you can see, it gives us a summary here. So it says this data file has 12 rows and 3 columns. And this is the data and what it looks like. I walk you through some things here. Let me, I ask you how many rows and columns does it have? If you go back to the cheat sheet I had about some of the functions that we have on data tables, we can use them here. So let's do that. Let's type n row of my dat and execute this. It has 12 rows. I mean, we knew that from the output here because it said we have 12 rows, but this is just a way to confirm that. Let me just show you this view function, which is really pretty cool. If you type view with a capital V, again, you have to be specific here. You have to use the capital V. But if you do view my dat and execute this line of code, watch what happens. It brings up a new tab here in RStudio. And this is now an interactive data table. And in fact, you can sort the data here in this view. This will not affect anything in the data table itself. Okay, so the data table is still ordered in the same way that we have it. This is just a way for you to interactively look at the table. There's a little search field here, so you can search for things in the table. This is just a nice way to interactively look at data if you'd like to. Okay, to get back to your script, you can either close this or you can click on that tab to get back to the data. All right. And again, let's practice this here about getting a specific column of data. So look at my dat here. If we wanted to get the values of the bioreplicate column, we're going to type $. R is suggesting some things for us, interestingly. RStudio is. The bioreplicate column, we can use our arrow keys to arrow down, and we can hit the return key that will complete that for us. And if we press return, we now get a vector out of all of the bioreplicate values. Okay, so let me do that again. So my dat $biorep, we get the vector and we can do math on this. So this doesn't make sense in this particular case because it's a sort of an index representing bioreplicate. But what if we wanted to get the mean of these values? We can call this mean function on the bioreplicate column of data, and it gives us 2.5. So we've done some math now here on data in our table using the $ to get access to that data in this function here, mean, that we learned about before, to work with vectors in order to do some math. Okay, let me briefly pause. Any questions there about one, reading data tables and doing some basic manipulation on them? Okay, so we have some practice here. Like I said, I covered this live here. Like this last one here, I kind of went over this with the mean, but using code, get the maximum of the bioreplicate value. So you could try to practice that using one of the other functions to understand what that is. Okay, we're going to cover, this is one of the last concepts we're going to cover here for today. This is about the idea of subsetting data frames. Like I said, this is a fundamental concept for data analysis. It's something I do every day. A motivation example might be, give me all the peptides or protein groups that have a false discovery rate of less than 1%. This is exactly how you would do that using R. We're going to, again, remember when we talked about vectors, we used the square brackets to get pieces of the vectors. We're going to use the exact same syntax here to get pieces of a data table. But because a data table has both rows and columns, it's a rectangular data table, we have to use slightly more complex syntax, meaning we have to specify what rows we want, followed by a comma, and then what columns we want. Okay, so it looks just like the vector stuff before, but slightly more complex because we have a slightly more complex type of data. That is a data table. This is probably one of the most complex slides we have here in the first section here. There's a lot of information here and you can go through it in detail, but I talk about how you can give these row selections or these column selections here. So these row selections can be a vector of integer numbers like 1, 2, 3, 4, 5, and that will give you that particular row number in the data table. You often actually don't use this too much in practice. You use these conditional expressions that we looked at before to make row selections. So again, I keep coming back to this example, but if you wanted to get peptides with a false discovery rate of less than 1%, you would make a conditional expression that asked that question, and then you would use that as a row selection in your data table to get those rows. You also have to specify what columns you want. And again, you can do that using numbers. So you can get the first column or the first and third column and so on. You can use numbers to do that. You can also give the column names themselves specifically. So if you wanted the bioreplicate column, you could use that as a column name. Just note, this is a little, you have to put quotes around the name in this particular syntax. You saw when we used that $ operator, we didn't put quotes. In this case, you have to do that. It's just one of the quirks of R, something that you'll get used to as you work with the R code more and more. You can also use conditional expressions, but you often don't use that. For row selections, you use conditional expressions all the time. For column selections, you typically use column names because it just makes it easier to work with. Here's a little tip here. You can use this column operator if you want to make a sequence of numbers 1 to 5, just a little note, because we'll see that in just a minute to make the code more concise. So 1:5 is exactly the same code as if we made this vector using the C function with the numbers 1 to 5. If you do not use a row and column selection, you can still use these brackets and you'll get the full data table back out, but you always have to put a comma here between things. So if you don't put the comma there, it will give you an error that will pop out. Okay, so we are going to combine a bunch of stuff that we learned together in a sort of a single kind of piece here. And we're going to work with the table. Let me go through this live again. You can cover this, you know, on your own as well. But let's go back to our code where we read our data table in. And the first thing we want to do is get the first 5 rows of the table only and all of the columns in the data set. So let's take a look at what that might look like. So let's take my data. We want to get the first 5 rows. So we're going to type our data here. Again, we need to use the bracket notation. That's how we subset data. And we're going to use integer notation here to get the first 5 rows of the data. So we can do it in 2 ways. We can make a vector here with the numbers 1, 2, 3, 4, 5. Okay, that's one way we could do it. We can also use that colon notation. I'll show that in a second. We then, very importantly, need to put a comma here. And if we don't add anything else here, that just tells R that says, give us all of the columns in the data. So let's execute this. Again, let's take a look at my data. Remember, it had 12 rows in it. Okay, 12 rows. If we execute this line of code now, we get just the first 5 rows of data. Okay, and because we didn't specify any column here, we got all the columns. This says get all the rows and only the last two columns of the data set. So we're going to use a combination here. So now if we want to get the last 2 columns, we can see that's condition and bioreplicate. So we can make a vector here that uses those exact names. So again, we're going to use the C function. That's our vector operator to make a vector. We're going to put condition, comma, bioreplicate. Oh, and the R is capitalized. I'm looking down here at the table. So if we execute this line of code, now we get a new table out, but we've only got the first 5 rows and only the condition and bioreplicate columns. All right, so that's some basic operations there. Let's now do another piece here. Get the rows that correspond to condition 4 only. Okay, so let's look at our table, my dat. So we have the condition table. Let's say we only want these rows where condition 4 is used. How would we do that? We're going to use the conditional expression. Remember, conditional expressions allow us to ask yes, no questions about our data. And the question we want to ask is, give me which rows have a condition equal to condition equal condition 4. Let me show you what that code looks like. So we're going to do my dat, and we're going to filter the rows of the data here. So we're going to make a conditional expression. And what we're going to say here is we're going to say my dat $ condition. Okay, we just saw this. Remember, the $ gives us all of the values in a given column. So it says, give me all of these condition variables. In fact, let me break that down in its own piece here. It'll be easier to see. If we do my dat $ condition and execute, we get all of these conditions here that come out as a vector. Let's add on to this. Let's ask the question where we use the double equal sign and put condition 4. Okay, we're asking the question, which values in our condition vector equal condition 4, and we have a double equal sign here. Remember, we don't want to do a single equal sign because that is assignment. Let's run this line of code. We should get a bunch of true and false values out, corresponding to all the pieces where the condition was equal to condition 4. As we can kind of see, these last 4 entries, as we'd expect, are condition 4. Let's take this piece of code now that we wrote and dump it inside of our bracket notation. Remember, we have to put a comma there. And because we want all the columns, we'll just leave that as is. And let's execute this expression. Now we got a piece of the data table that only corresponds to places where condition is equal to 4. All right, so that was quite a bit of code here. I have to admit, a little bit complex, but we've learned all of the individual pieces to make this happen here. And so I bet you could maybe now think of a way to maybe read a protein table into R that you have with your own data And I could probably imagine you being able to, with some of these examples, and maybe going back and looking at some of the examples, being able to take your table and filter that table to get peptides and proteins that have a false discovery rate of less than 1%, or have a mass to charge ratio bigger than some value, or some peptides that elute in a given elution time in your gradient. All right. Okay. So that covers the main fundamental pieces of what I wanted to cover with R, and the fundamental pieces of working with R. I'm going to do a little bit of a wrap up here and point you to some pieces that we can work on in practice. But any questions about sort of particularly this last piece here about reading data files and doing some basic operations and manipulations on them? Any questions? So again, I would really recommend going through the slides, particularly these slides that have these blue tables, show some example code and functions here, and some example outputs. So you can run these codes in the R editor yourself and work with these things and maybe try some different examples, and you can kind of see the outputs and see where you're going. A lot about learning R is frankly just exploring things for yourself. And what's really cool, compared to the lab, you usually need to be careful about what you're doing in the lab. You don't want to mix two chemicals together just to test things about what happened. You might cause problems, health problems, safety issues. Generally speaking, with code, you can do anything you want. There are some cases where edge cases where you might, do some things or erase things by accident, but that's not going to happen, except in some really strange cases. So please experiment with writing R code. Make mistakes, try to learn from those mistakes, try to use that as an opportunity to learn. So experiment. That is going to be a really key piece to learning R. So let me now come to a recap here. So what did we just cover? We talked about data frames, talked about reading things in R, and how we can essentially work with some data. I hope, lots of data, lots of information that we covered here in this first day, a lot to go through, but hopefully you can see that there are some pieces here that might actually be helpful in the work that you do in your daily sort of day-to-day work, either at work or at school. There is some homework I'd like you to think about. If you go to the GitHub repository here, and you go to exercises, we have two exercises. These are R files here. They're day one exercises, and they cover essentially the main pieces that we have worked on. These are R scripts here. Sorry, I didn't cover this, but if you want to, from the main repository, if you go into code and click download as zip, it will download everything as a zip file, and you'll get all this stuff here, including the lecture slide, including the data, including the exercises. So you can take these R files and copy them into your own RStudio project to work with them. So let me just show you what this is here. This is an R script that walks you through data. In fact, do I have this? I think I do. Let me open this up in RStudio so you can see this. All right, so this is one of the examples here. There's some new syntax here. Notice how these lines are green. There's a pound sign in the front. These are known as comments. Okay, when you write code, comments are a way for you to tell the author, or frankly tell yourself or your future self, what you're doing and why you're doing it. So if you put a pound sign in here, R will ignore this. It will not execute any lines that start with a pound. It's a place for you to put text, to write information about what you're doing, why you're doing it, and some information about your code. So just note that. And so I've put a bunch of stuff here in, most of these things are comments here. So with exercise 1 here, you have the questions here, and this is about working with variables. So I want you to create a variable, for example. I want you to convert the variable from seconds to from minutes to seconds, and so on. We have some exercises working with vectors. I give you a vector here to work with, and essentially working through some of the main concepts concepts that we're working on. Okay, so that's one of the examples of working with some of those fundamentals. I also have another one here that's working with data frames and data tables. So I ask you to load this particular Skyline output. This is, again, some proteomics data here, some real proteomics data. This is the other file. This is the input file. This is about 200 megabytes of data. There was a question about this guess max. What does that do? This effectively helps the read function read the data in properly. So you can just sort of leave that as for now, but you can use this to execute the code. And then I want you to go and answer some questions about this data. And in fact, do some things. How many unique peptides are present in this for a particular protein? That might be a question you might want to ask. That's one of the things I'll ask you to explore. So please, if you have time, please do your best to practice today's materials doing those exercises. I will cover those live tomorrow. So we'll go through these exercises at the beginning of tomorrow's sessions. Want to thank Olga, obviously, for organizing this, and our TAs. I bet there's lots of questions that have been going on in the background. Thank you for taking care of that. I couldn't do this, frankly, without you, particularly in this virtual environment. The TAs are just absolutely critical for being able to do these things virtually, and certainly appreciate all of your efforts. And let me thank you, frankly. We covered a lot of material, particularly if you're a beginner. There was a lot here. I hope you will find that these are basic building blocks to using R, and maybe you can even think about using R now in your own work. Thank you for sticking through here. It's hard to be on Zoom. We're already on Zoom enough, and thank you for sticking through this 3-hour session, which is a long time here. We will continue tomorrow. We're going to build upon what we learned today, and we're going to talk about maybe slightly more interesting in the sense that we're going to be working with data and talk about how we can do some really cool data analysis pipelines using the tidyverse and the dplyr package. So let me stop for now and maybe hand it over to any questions. I think at this point you can ask questions in the Q&A. If anybody wants to, unmute, I think we have the ability to do that as well. So let me also note that in the May Institute documents, my email address is up here. Right here. Please feel free to email me if you have any questions before now. Well, before is too late now. We're already in the future, but after the course, please feel free to email me. I know there's lots of stumbling blocks and speed bumps. I am more than happy to help. Would love to be able to help anybody here if they have anything. If you need input on our, advice, troubleshoot, I am more than happy to help you. Please feel free to reach out to me through my email address. I'd love to answer any questions you have. So we will leave it at that for questions. I suspect people probably want to go and maybe take a break as well. So if you have any questions, write them down and we can bring them up. We can cover them live tomorrow morning as well in our next session tomorrow. See how we're doing. I think you went through and answered the questions pretty well, so that's great. Thank you. So I'll stick around here until, I guess 11:15 is when we're going to go. Looks like we don't have any questions, but I'll stick around here for a few more minutes if anybody has any questions. Thank you all for your comments there. Like I said, yeah, feel free to reach out to me. Anything, when you go and start working with it, I think you will probably run into some issues, undoubtedly. Feel free to reach out. Be happy to answer those.
Ryan, looks like there is a question of how to tell your our data is in the subfolder.
How did a great question. Is it in the subfolder in your RStudio project? So what I would recommend is going to, I guess I can share my screen again. Go to the directory on your computer's file system. Okay, so go and find where it is. And on Windows, there's different pieces here, but go to that directory and look in that directory and make sure that that data file is there. Okay, so that's how you would confirm. So you can see it in RStudio as well. It will show up here in this file browser, but probably the most direct way is just go to your computer's browser and make sure it's there. If it's not there, then again, use your computer's file browser to drag and drop or move that file into that directory. The RStudio projects are they're just folders on your computer. So you just can treat them that way. Okay, so thanks, Ian. This is there an RStudio for dummies? That's a great question. I'm not aware of it, really. I don't know, TAs, have you ever seen like an RStudio for dummies? What typically happens is that in other R books that I can recommend, RStudio will kind of be used as a backdrop and you might get tips and hints from there. But generally speaking, there really isn't one. I think it actually would be useful. Maybe that's, maybe if you become an expert in here, you can write an RStudio book for dummies, because I think that would be a great thing. I haven't seen one. I'm not aware of one. I'll do some research. If I find some, I'll let you know tomorrow. Okay, great. So I think, people are kind of dropping off here. Any last minute questions? Again, feel free, we can ask questions tomorrow as well at tomorrow's session. All right, everybody. Sarah, Vartika, Rohan, thank you very much for helping me out today, managing the chat and managing the Q&A. Thank you, everybody, if you're still sticking around. We will resume tomorrow, and looking forward to seeing you then. If you have any questions, we can address those in the morning as well. So I guess we will sign off. Sarah, is there anything else we need to do here?
Just wanted to thank you.
Great. Thank you. Okay, great. All right. Well, thank you very much, and we'll see you guys tomorrow. Thanks so much.
Thank you, everyone.
Yeah.
Bye.
Thank you.
Bye.